In the annals of human ingenuity, few machines command the raw respect and awe of the great locomotive. They are more than just steel and fire, they are monuments to the limits we dared to push. For over a century, engineers relentlessly pursued a single goal: power. To move more, to go faster, to conquer mountains and deserts with sheer mechanical force. Today we delve into the heart of that ambition. We are counting down the 10 largest and most powerful locomotives humanity ever placed on rails. The sheer size of these iron giants, the articulated steam beasts, the colossal diesel electrics, and the specialized monsters will challenge everything you think you know about rail travel. First, a challenge for you. Before we even start, hit that subscribe button and tell us in the comments which locomotive you think will claim the title of the undisputed king. Can the big boy be beaten? Let's find out. We begin with a machine that defied its time and shattered expectations, proving that raw power wasn't limited to sheer bulk. This is the MOV 242.001, a sleek 4-4-4 steam engine born in Hungary in 1937, designed not for pulling coal but for blistering speed. Its white notation, the 444, denotes 4 leading wheels, 4 coupled drive wheels, and 4 trailing wheels, giving it remarkable stability at velocity. But don't let its comparatively slender frame fool you. This was a technological pioneer. The Speed Demon was designed by the renowned Hungarian engineer Ferenc Liptak, specifically to haul heavy express trains across the flat plains of Hungary at phenomenal speeds. It wasn't the largest, but it possessed immense power-to-weight ratio and a groundbreaking streamlined casing that dramatically reduced air resistance, a true marvel of pre-war European design. Its confirmed top speed approached 140 km/h, 87 linya, making it one of the fastest of its time, easily outperforming many contemporary designs built for sheer brute force. Its service life was tragically cut short by the chaos of World War II, during which the original locomotive was lost. However, its memory and its engineering legacy persist, demonstrating that the pursuit of speed was just as intense as the hunt for tonnage capacity. It showed that streamlined design could unlock hidden power. From high-speed runs, we turn to the grueling, water-scarce environment of South Africa. Meet the South African Railways Class 25, a powerful and unique 484 steam locomotive designed to tackle one of the continent's most challenging problems: water scarcity. Introduced in the 1950s, this wasn't just a powerful engine, it was a self-sustaining ecosystem built on rails. The true genius of the Class 25 was its revolutionary condensing tender. In most steam engines, steam is exhausted into the atmosphere, wasting precious water. The Class 25, however, routed the exhaust steam through massive air-cooled radiators in its tender, turning it back into water for reuse. This allowed the engine to travel vast distances, up to 800 miles, without taking on water, making it the perfect workhorse for the arid Karoo region. The 25C variant, the condensing model, made the engine heavier and bulkier, adding to its impressive stature. This feature was absolutely critical for maintaining the efficiency of South Africa's vast railway network, often hauling heavy freight and passenger traffic. The sheer reliability and operational savings the condensing system provided allowed the Class 25 to remain in service for decades, long after many other countries had transitioned away from steam. Its 4-8-4 wheel arrangement provided the perfect balance of pulling power and high-speed running capability. Back in the United States, we encounter one of the most beautiful and effective steam engines ever conceived, the Norfolk and Western J-Class 611. Built by the N&W's own shops, this 484 streamlined queen was the crown jewel of their passenger service. Combining elegance with incredible power, the J-Class could maintain speeds over 100 km/h while effortlessly pulling heavy passenger consists, making it an icon of American railroading. The N&W 611 was a masterclass in balance and efficiency. Its design prioritized high-speed stability and low maintenance, boasting roller bearings on all axles, a state-of-the-art feature for the 1950s. While not the largest by overall dimensions, its horsepower output was phenomenal for a conventional 4-8-4, ensuring it remained punctual regardless of the terrain of the Appalachian Mountains. The engine was an immediate success, known for its smooth ride and capacity to handle the fastest schedules across the N&W lines. What makes the 611 truly legendary is its survival and subsequent return to mainline service. It's one of the few steam locomotives that has run at speeds that rivaled and often exceeded modern diesel passenger units, proving the enduring capability of its design. The streamlining was more than cosmetic. It was a functional part of its high-speed performance, setting a visual standard for passenger trains that is still admired today. The 611 represents the peak of standardized high-performance steam passenger technology in the U.S. Next, we honor the pioneering spirit of the Atchison, Topeka, and Santa Fe Railway with the Santa Fe 5000, known affectionately as the Madame Queen. This was a landmark locomotive, the first 210-4 type built in the United States and a true champion of heavy freight hauling. Delivered in 1930, the Madame Queen was designed to conquer the challenging grades of the Santa Fe's western lines, particularly the legendary Abo Canyon route in New Mexico. The 2-10-4 wheel arrangement, meaning 2 leading wheels, 10 massive driving wheels, and 4 trailing wheels, was revolutionary. The 10 driving wheels gave it an unparalleled adhesion and the sheer tractive effort required to pull heavy tonnage over steep inclines. The 4-wheel trailing truck was essential to support its enormous firebox, allowing the locomotive to generate the vast quantities of steam needed for a continuous, high-output operation. This combination of tractive effort and steaming capacity made it an instant success. The performance of the single Santa Fe 5000 was so spectacular that it led to the rapid development of the subsequent and highly successful 2-10-4 classes, often known as the Texas type, that later became common. The Madame Queen proved the 2-10-4 configuration was superior for the grueling tasks facing American heavy freight railroads in the era, setting the blueprint for massive freight power for the next 2 decades. Our journey now takes a dramatic turn across the Atlantic to the Soviet Union, where sheer size was often an expression of national pride and industrial might. Here is the Soviet AA-21, a steam locomotive so massive, its wheel arrangement is almost impossible to comprehend, the staggering 414-4. This single experimental engine holds the world record for the most driving axles on a single rigid frame, 7 sets of coupled wheels. The AA-21 was constructed in 1934 and was intended to be the ultimate freight hauler on the Soviet railway network. The logic behind the 14 driving wheels was simple: to maximize the engine's adhesion and distribute the colossal weight of the locomotive across the tracks. The Soviet engineering marvel utilized an articulated frame and a massive boiler to attempt to achieve unparalleled pulling power, a true statement of Stalinist industrial ambition. However, the AA-21 was a classic case of ambitious engineering exceeding practical infrastructure. Its immense size and rigid frame proved incompatible with the sharp curves and standard track infrastructure of the Soviet railways. The excessive length and weight resulted in frequent derailments and track damage, meaning it spent more time in the shop than on the main line. Despite its technical failure, its existence remains a potent symbol of the global race to build the biggest, most powerful machine imaginable. Not all power is measured in tractive effort. Sometimes it's measured in sheer, unstoppable force against nature. The Union Pacific Rotary. Snowplow is a highly specialized, self-contained machine designed for one purpose: to annihilate blizzards. While technically not a locomotive that pulls freight, it is a mobile powerhouse that clears the way for all other locomotives, demanding immense power to operate its main feature, the massive rotary blade. These plows were indispensable in the mountainous, snow-prone regions of the western United States. Unlike traditional wedge plows, which merely push snow aside, the rotary plow uses a colossal, rapidly spinning wheel, fitted with blades to chew through drifts up to 20 feet high, throwing the snow clear of the tracks. The power required to turn this wheel against compacted snow and ice is immense, often requiring one or two powerful locomotives, often challengers or big boys, to push the plow forward and another one to power the rotary mechanism itself. The rotary snowplow represents the ultimate extreme of engineering adapted to environmental challenges. When the line was blocked, hundreds of tons of freight and passengers were paralyzed. The arrival of the Blizzard destroyer, often powered by a tender full of oil and fire, signaled the immediate resumption of traffic. It is a spectacular and terrifying machine in action, a true spectacle of raw mechanical work. We now arrive at one of the workhorses that truly define the American West, the Union Pacific Challenger, specifically the 3985. The Challenger, a 4-664 articulated locomotive, was developed in the 1930s to handle the rapidly increasing tonnage on the Union Pacific Railroad. It was slightly smaller than its famous cousin, the Big Boy, but designed for high-speed freight service, making it an incredibly versatile and powerful machine. The key to the Freight Titan's versatility lay in its articulated design, allowing the long wheelbase to navigate curves that would have been impossible for a rigid-frame locomotive of its size. The 4-664 configuration meant it had two sets of 6 coupled driving wheels, giving it enormous tractive effort, yet it was engineered to cruise comfortably at speeds nearing 70 mph, a remarkable feat for a machine built primarily for freight hauling. It became the backbone of UP's fast freight operations, seamlessly bridging the gap between slow, brute force engines and high-speed passenger locomotives. The 3985 itself, one of the last Challengers built, has achieved a special legendary status in preservation. Its successful operation demonstrated that large articulated steam power could be highly efficient and adaptable. The Challenger proved that railroads needed a powerful machine that could haul colossal weight and maintain a respectable schedule, a crucial factor in the competitive U.S. rail market. If there is one locomotive that truly challenged the Big Boy for the title of most powerful steam locomotive, it is the Chesapeake and Ohio C&O H8 Allegheny. This 2-6-6-6 articulated monster was built specifically to haul heavy coal trains over the steep grades of the Allegheny Mountains in West Virginia, a task that demanded the absolute maximum output possible from a steam engine. The Allegheny's distinguishing feature was its 2-6-6-6 wheel arrangement, incorporating a unique 6-wheel trailing truck. This was necessary to support its massive, high-capacity firebox, which was the largest ever installed on a steam locomotive. This firebox was the engine's heart, designed to generate steam pressure at an incredible rate, pushing its horsepower output up to a claimed 7,500 horsepower. This immense power rating made it, arguably, the most powerful reciprocating steam locomotive ever built in terms of horsepower developed. The size of the Allegheny was astonishing. It was one of the heaviest and most intimidating locomotives ever to run, primarily serving the grueling coal traffic routes. Its raw power ensured that the C&O could move vital coal supplies efficiently, cementing its reputation as the power king of the eastern railroads. The rivalry between the Allegheny for horsepower and the Big Boy for tractive effort C weight is one of the most famous debates in rail history. Stepping into the modern era, we encounter the true king of diesel electrics, the EMD DDA-40X Centennial. Built by Electromotive Division, EMD, for the Union Pacific Railroad, this monumental locomotive was unveiled in 1969 to commemorate the 100th anniversary of the completion of the Transcontinental Railroad. It is to this day the longest single-unit diesel locomotive ever built. The Diesel Goliath is essentially two powerful diesel-electric units combined into one enormous 98-foot-long rigid frame. It was powered by two separate 16-cylinder diesel engines, providing a combined output of 6,600 horsepower. The DDA-40X was designed for high-speed freight service, often working across the flat plains and mountainous regions of the Union Pacific system. Its sheer size required a modified version of the DD axle arrangement, which spread the weight and power across 8 axles. The Centennial demonstrated the peak capabilities of U.S. diesel engineering. It offered unparalleled reliability and required significantly less maintenance than the steam engines it replaced. The ability to haul the heaviest trains at higher speeds with a single crew was an economic game-changer for the railroad. Only 47 of these unique units were ever built, and their legacy remains unchallenged as the longest and one of the most powerful diesel locomotives in continuous service. We have arrived, holding the title that all others measure themselves against, the Union Pacific Big Boy. This colossal 4884 articulated steam locomotive is widely regarded as the largest and most powerful steam engine ever to operate globally. Built in the early 1940s, the Big Boy was designed for one overwhelming purpose: to haul 4,000-ton freight trains unassisted over the steepest grades of the Wasatch Mountains. Its engineering was simply staggering. The 4884 wheel arrangement means it had 2 massive engines built into one frame, giving it the ability to articulate and navigate curves. It measured over 132 feet long, including the tender, and developed an enormous 135,375 pounds of tractive effort, a figure that remains unmatched by almost any other locomotive ever conceived. It was the ultimate weapon in the battle against gravity and immense tonnage. The Big Boy was so effective that it fundamentally changed the logistics of the Union Pacific, making double-heading, using 2 locomotives, unnecessary on its toughest routes. Of the 25 built, 8 survive, including the famed UP 4014, which has been returned to operational status, thrilling crowds worldwide and proving that its decades-old design can still dominate the tracks. The Big Boy is not just a machine, it is a mechanical legend, the undisputed symbol of power on the rails. We've witnessed the Speed Demon, the Desert Workhorse, the Power King, and the Diesel Goliath. These 10 machines, from the rapid MAV 242 to Z01 to the gargantuan Big Boy, represent the pinnacle of human engineering and the relentless quest for greater power. They remind us that before the age of computers, ingenuity was forged in fire and steel. They are living, breathing proof of what is possible when ambition meets mechanics. If you love this journey through railroad history, please like this video, share it with a fellow enthusiast, and if you haven't already, subscribe to the channel for more deep dives into the world's greatest machines. We are waiting for your vote in the comments. Forget what you think you know about trains. We're not talking about your average commuter rail. We're talking about titans of steel, mechanical monsters so massive they defy belief, and so powerful they literally moved mountains. These are the largest, heaviest, and most extreme locomotives ever built, and many of them have stories you've never heard. Why were these behemoths created? And what secrets did they take to the scrap heap? By the end of this video, you'll see engineering in a whole new light. We guarantee you'll be shocked by number 7. Which machine will blow your mind? Let us know in the comments which one you think is the ultimate giant, and subscribe right now so you never miss another story of epic engineering. When you hear giant locomotive, one name echoes above all: Big Boy. The Union Pacific 4014 is the undisputed king, a living legend, and the largest operational steam locomotive in the world. But its fame isn't just about size, it's about purpose. Born in the 1940s, the Big Boys were designed for one reason: to conquer the brutal Wasatch Mountains in Utah. They needed to pull immensely heavy freight trains over steep grades unassisted, a job that previously required multiple smaller engines. The scale of a Big Boy is staggering. It's an articulated locomotive, meaning it has 2 sets of massive driving wheels, allowing it to navigate curves despite its colossal length of over 132 feet, longer than 2 city buses. Weighing in at 1.2 million pounds with its tender, it's one of the heaviest locomotives ever built. But its true strength was its power, a staggering 6,290 horsepower. This wasn't just a train, it was a self-propelled industrial revolution on wheels, thundering across the American West. What most people don't know is why they were called Big Boy. The name wasn't from a corporate committee. An unknown worker at the American Locomotive Company, ALCO, simply scrawled Big Boy in chalk on the front of the 4000 smokebox during construction. The name stuck. The perfect simple title for the most complex and powerful steam engine America, and arguably the world, had ever produced. Of the 25 built, 8 survive, but only one, number 4014, roams the rails today, a thundering reminder of when steam was king. If Big Boy was the king of steam, the EMD DDA-40X was the emperor of diesel. Built by EMD in 1969, these locomotives were a celebration of the 100th anniversary of the Golden Spike Ceremony, which completed the first transcontinental railroad. And what a celebration it was. To this day, the Centennial holds the world record as the most powerful single-unit diesel-electric locomotive ever built. It wasn't two engines coupled together. It was one single gargantuan frame. The DDA-40X is an exercise in excess. At 98 feet long, it was so massive it earned the nickname King of the Rails. Inside its cavernous body, it housed not one but two 16-cylinder, 3,300 horsepower diesel engines, giving it a combined total of 6,600 horsepower. This twin-engine setup gave it incredible reliability. If one engine failed, it could still operate on the other. It was a high-speed freight hauler designed to pull heavy loads at speeds of up to 90 miles per hour, a blistering pace for freight in its day. But here's the part you won't believe. Despite their power, their reign was surprisingly short. Union Pacific was the only railroad to ever order them, and only 47 were built. Why? They were simply too big and too complex. Their immense length was hard on the tracks, and maintenance was a nightmare, essentially requiring technicians to service two engines in one. By the mid-1980s, they were all retired, replaced by smaller, more efficient, and more flexible locomotives. Today, 13 survive, including one operational unit, a magnificent monument to a time when bigger was always better. While the Big Boy gets all the fame, many railroad experts will argue that this was the true heavyweight champion. Meet the Allegheny H8, built for the Chesapeake and Ohio Railway, C&O. These locomotives were not designed for speed, they were designed for one thing: raw, brutal pulling power. Their job was to haul mind-numbingly heavy coal trains out of the deep valleys of the Allegheny Mountains in West Virginia. This was speed, high-tractive effort work at its most extreme. The numbers are simply monstrous. The Allegheny H8 is widely considered the heaviest steam locomotive ever built, tipping the scales at over 1.2 million pounds with its tender. But its real claim to fame was its power output. While the Big Boy was rated at 6,290 horsepower, the Allegheny was officially rated at 7,500 horsepower, making it the most powerful steam locomotive ever constructed. Its firebox grate was enormous, 135 square feet, necessary to burn the sheer volume of coal needed to generate that much steam. But the most unbelievable part of the Allegheny story is its tragic obscurity. These engines were so heavy that they systematically destroyed the very tracks they ran on, causing massive maintenance headaches for the C&O. Furthermore, they were delivered just as the diesel era was dawning, and their incredible power was quickly overshadowed by the efficiency of the new technology. Only 60 were built, and they were all scrapped by 1956 after very short service lives. Only 2 survive, quiet reminders of a machine that was arguably too powerful for its own good. Enter the modern era of monster locomotives. In the 1990s, a horsepower war ignited between America's 2 rail giants, General Electric, GE, and General Motors, EMD. The result was this: the GE AC6000 CW. This locomotive is, simply put, the most powerful single-engine diesel-electric locomotive ever built. While the DDA-40X had 2 engines, the AC6000 CW does its work with one massive prime mover. The heart of this beast is the GE 7FDL16 engine, a 16-cylinder powerhouse that produced a staggering 6,000 horsepower and in testing was pushed to 6,250. This engine was so advanced and powerful that it became the locomotive's greatest strength and its greatest weakness. Coupled with state-of-the-art AC traction motors, the AC 6000 CW had a tractive effort that could restart a heavy train on a steep grade, making it a favorite for heavy haul routes. When you see one of these, you are looking at the pinnacle of 20th century diesel power. But here's the catch. That 6,000 horsepower engine was notoriously unreliable. It was pushed to its absolute limits, and the initial units were plagued with mechanical failures, including turbocharger problems and severe vibrations. GE and the railroad spent years trying to iron out the kinks. By the time they did, stricter emission standards were on the horizon, making the massive engine obsolete. Many AC 6000 CWs were actually derated to 4,400 horsepower for reliability. Today, they still thunder across the rails, but they stand as a lesson that power isn't everything if you can't control it. Half a world away in the freezing darkness of the Arctic Circle exists a locomotive built for a task so extreme it requires a machine unlike any other. This is the Bombardier Iora, a twin-unit electric locomotive operated by LKAB in Sweden. Its sole purpose is to haul the Malmbanan, or iron ore line, one of the heaviest and most demanding rail routes on Earth. These trains carry iron ore from mines in Kiruna, Sweden, to the ice-free port of Narvik, Norway, 24 hours a day, 365 days a year. The Iora is the definition of modern power. Each twin-unit locomotive consists of two identical sections permanently coupled together. Combined, they are over 148 feet long and weigh 360 metric tons. They produce a continuous 10,800 kilowatts, which translates to a mind-bending 14,500 horsepower. This, combined with their immense weight, makes them the most powerful locomotives in the world, capable of pulling 68-car trains loaded with 8,600 tons of iron ore through brutal snow, ice, and grades. What you won't believe is the environment they work in. These engines operate in temperatures that regularly plunge to 40 degrees Celsius. They are designed to be serviceable in extreme cold, and their power is necessary not just to pull the load, but to fight the elements. Unlike the historic engines on this list, the Iora is a modern marvel, a highly specialized tool built for one of the most inhospitable jobs on the planet. They aren't just big for show, they are big because they have to be. This might be the most futuristic, bizarre, and ultimately tragic giant on our list. Built in 1939 for the Pennsylvania Railroad, PRR, the S1 was nicknamed the Big Engine, and it was. It was the longest and heaviest rigid-frame steam locomotive ever built, stretching to an unbelievable 140 feet. But it wasn't a slow freight hauler. It was an experimental passenger locomotive designed to pull 1,000-ton passenger trains at over 100 miles per hour. The S1 was a true duplex locomotive, meaning it had two sets of driving wheels in one rigid frame, unlike the articulated Big Boy. This 6-4-4-6 wheel arrangement was unique. Visually, it was a masterpiece, with a stunning streamlined shroud designed by the legendary Raymond Loewy. It was famously displayed at the 1939 New York World's Fair, where it ran on a dynamometer, captivating crowds. It was, in theory, the future of steam power, capable of producing over 7,200 horsepower. But the S1 was a spectacular failure. Its rigid frame was simply too long for the PRR's tracks, limiting it to just one route between Chicago and Crestline, Ohio. It was also notoriously prone to violent wheel slip. Its four cylinders were so powerful that the front and rear engines would often slip at different speeds, tearing the locomotive apart. It was a maintenance black hole and a driver's nightmare. It was quietly retired in 1946, and despite its fame and one-of-a-kind status, was unceremoniously scrapped in 1949. It was a machine that was too big, too ambitious, and too far ahead of its time. Prepare to enter the bizarre world of Soviet super-engineering. This is the AA-21, and it holds the undisputed record as the steam locomotive with the most driving axles in the world. While a big boy had 8 driving axles, 4 on each engine, the A2001 had a mind-boggling 14 driving axles, split between 3 sets of wheels, all housed in one colossal semi-articulated frame. It was the Soviet Union's attempt to create the ultimate freight engine. Built in 1934, the A2001 was a true monster. It was over 110 feet long and was designed to solve the problem of axle load. Soviet tracks were often lighter duty than American ones, so instead of making the engine heavier on a few axles, they spread the weight across many. With its 7-axle mainframe and a 7-axle tender that also had driving wheels, it was a completely unique design. It was intended to be the standard for heavy freight across the USSR. But here's why you've never heard of it. It was a catastrophic disaster. The design was hopelessly complex. The steam pipes feeding the tender engine were inefficient, and the whole machine was too rigid, despite its articulation, to handle the curves of Soviet railways. It derailed constantly and was so damaging to the track that it was almost unusable. After just a few trial runs, it was deemed a total failure, nicknamed the American Soviet due to its 4-14-4 wheel arrangement, which looked like a 2-8-8-2 plus 2-6-2 and quietly stored. It was scrapped in 1960, a forgotten testament to an engineering dream that turned into a nightmare. Not all giants are from the past. Meet the China DF-11G, a high-speed diesel locomotive that represents the pinnacle of modern passenger rail in a country obsessed with speed. Built by Kishuyan Locomotive Works, the DF-11G is a quasi-high-speed locomotive designed to pull long, heavy passenger trains at speeds up to 106 miles per hour, 170 km/h, on China's rapidly expanding rail network. Like the DDA-40X, the DF-11G is a twin-unit locomotive composed of 2 identical sections permanently coupled together. Each section has its own 16-cylinder diesel engine, giving the locomotive a combined total of nearly 10,000 horsepower. This immense power is necessary to accelerate long 20-car sleeper trains quickly and maintain high speeds over long distances. They are a common sight on major routes, such as Beijing to Shanghai, pulling double-decker passenger cars. This locomotive is a giant born from a unique constraint. South Africa, like many Commonwealth countries, uses Cape gauge railways, which are narrower than the standard gauge used in North America and Europe. This narrow gauge severely limits the width and therefore the size of a locomotive. To build a powerful engine, you have to build long, and that is exactly what they did with the Class 25. The Class 25, introduced in 1953, was the ultimate expression of steam power on the Cape gauge. To get the power they needed, the designers at North British Locomotive Company and Henschel and Son created a massive articulated locomotive that was, for its gauge, one of the most powerful engines ever built. But its most incredible feature was its tender. The Class 25 was designed to cross the vast, arid Karoo Desert where water was non-existent. So they gave it a massive condensing tender. This wasn't just a water tank, it was a mobile cooling plant. Exhaust steam from the cylinders was piped back to the tender, where it was cooled by a series of massive fans turned back into water and fed back to the boiler. This system allowed the Class 25 to travel nearly 700 miles without refilling its water, an 80–90% water saving. It was a bizarre, complex, and brilliant solution, making the Class 25 not just a giant of power, but a giant of endurance. We end with a glimpse into the future of giant locomotives. This is the Siemens Vectron Dual Mode XXL, a machine that is less about brute force and more about extreme flexibility. In modern Europe, railway networks are a complex patchwork of electrified and non-electrified lines. This traditionally means trains must stop to change locomotives, wasting time and energy. The Vectron Dual Mode is designed to eliminate that problem entirely. As its name implies, this locomotive is a hybrid. On electrified routes, it runs as a powerful 9,000 horsepower, 6,700 kL electric locomotive, drawing power from overhead lines. But when it reaches the end of the wire, it doesn't stop. It simply fires up its powerful onboard 3,200 horsepower diesel engine and continues on its journey, pulling the same heavy freight train. This is two locomotives in one, a one-size-fits-all solution for the most complex rail network in the world. The XXL version is the key. While the standard Vectron dual mode is impressive, the XXL variant, built for Finnish operator Fenniarail, is adapted for the brutal cold of Scandinavia and the wider Finnish gauge. It's a massive 147-ton machine designed for heavy hauling in extreme conditions. This isn't a giant from the past built for one single brutal task. It's a modern, intelligent giant built to be a high-horsepower chameleon, and it's changing the face of European freight forever. From the steam-powered fury of the Big Boy and the Allegheny to the diesel-electric excess of the DDA-40X and the bizarre failed experiment of the Soviet AA-21, these machines are more than just trains. They are monuments of human ambition, testaments to our relentless drive to build bigger, faster, and more powerful. They pushed engineering to its absolute limits, and sometimes far beyond. What other engineering marvels should we cover? Let us know. And if you haven't already, hit that subscribe button and ring the bell. You don't want to miss what's next. What happens when you strap nuclear bomber engines to the roof of a rusty commuter train? The result isn't sci-fi, it is history. Today, forget everything you know about rails. We are witnessing a suicide train that climbs a vertical cliff face, a floating hotel that defies gravity, and a monster that has hung upside down over a river for 100 years. From the fastest magnetic beasts in Asia to the steepest tracks in the Alps, these engineering marvels will blow your mind. But be warned. Number 4 was so insane that the government literally erased it from existence. Don't blink, smash that subscribe button right now, because we are about to break the laws of physics. We are starting strong with something that looks like it came straight out of a mad scientist's lab. This is the M497, also known as the Black Beetle. In 1966, the New York Central Railroad was desperate to see if they could make trains run faster on standard tracks. Their solution was absolutely wild. They took a standard Bud Rail diesel car and strapped two surplus General Electric J4719 jet engines to the roof. Yes, these were the exact same engines used on a B-36 Peacemaker strategic bomber. The engineer behind this project, Don Wetzel, was a genius. He actually mounted the engines tilted slightly downwards towards the front. Why? To press the train firmly onto the tracks using thrust, ensuring it wouldn't literally take off and fly like an airplane at high speeds. This wasn't just a showpiece for the press. In July 1966, on a straight stretch of track in Ohio, the Black Beetle blasted down the rails, hitting a record-breaking speed of 183.68 miles per hour. That speed is still the light rail speed record in the United States today. Success, the project was scrapped. It simply wasn't practical to have jet engines screaming through quiet American towns, shattering windows and eardrums with their noise. The jet pods were removed and the car went back to being a normal, boring commuter train. But for a brief moment, America had a jet fighter on wheels, proving that the only limit to engineering is our imagination and maybe noise complaints. From brute force, we move to aerodynamic perfection. Meet the Shinkansen E5 series, the pride of Japan, often called the Hayabusa. When you first see it, you can't help but notice that incredibly long duckbill nose. It measures about 49 feet long. This isn't just for style, it solves a massive physics problem called the tunnel boom. Without this nose, entering a tunnel would create a pressure wave so strong it would sound like an explosion at the other end. The E5's long nose slices through the air, reducing that pressure wave and making the train whisper quiet, even while traveling at nearly 200 miles per hour. It is a masterclass in biomimicry, directly inspired by the beak of the kingfisher bird, which dives into water without making a splash. Japanese engineers studied nature to overcome industrial limitations. This design allows the train to run faster and quieter through densely populated areas without disturbing the people living nearby. But the engineering isn't just on the outside. The ride is so smooth that you can balance a coin on its edge while the train is sprinting at full speed. The E5 features a computer-controlled active suspension system that tilts the train into curves, neutralizing centrifugal force. If you step into the Grand carriage, it feels less like a train and more like a private jet, complete with leather shell seats. It is the perfect blend of speed, silence, and luxury. What if I told you the fastest commercial train in the world doesn't even touch the ground? This is the Shanghai Maglev. While other trains roll on wheels causing friction and vibration, the Maglev uses magnetic levitation to hover millimeters above the track. It is literally flying at zero altitude. This technology eliminates rolling resistance, allowing it to achieve mind-bending speeds that traditional trains can only dream of. It connects Shanghai Pudong International Airport to the city outskirts in a blink. This beast is designed to hit a top operational speed of 268 miles per hour, 431 km/h. Although it often runs at slightly lower speeds, around 186 mph today, to conserve energy and reduce maintenance, the capability is staggering. At full power, the 19-mile journey takes just over 7 minutes. By the time you buckle your seatbelt and open a bag of chips, you have already arrived. It feels less like public transport and more like a teleportation device. However, the Shanghai Maglev is somewhat of a lonely giant. Built with German technology, it was extremely expensive to construct, costing over $1 billion for a relatively short track. While plans to extend it have stalled due to massive costs and public concerns about radiation, riding it remains a bucket list experience. Feeling the G-force as it accelerates is the closest most people can get to being an astronaut on their way to work. It's a glimpse into a sci-fi future. Before the TGV became the icon of French speed, there was something far stranger and arguably cooler, the Bertin I-80 Aerotran. Developed by engineer Jean Bertin in the 1960s, this wasn't a train in the traditional sense. It was a hovercraft restricted to a guide rail. It rode on a cushion of air over a special inverted T-shaped concrete track. Without wheels, there was zero friction. It looked like a spaceship from a retro sci-fi movie cruising through the French countryside. To propel this beast, they mounted a massive turboprop engine at the rear, similar to what you would find on an aircraft. In 1974, the I-80 set a world speed record for overland air cushion vehicles at 267.4 miles per hour. It was loud, it was fast, and it was undeniably French. The plan was to build a network connecting Paris to other major cities, slashing travel times dramatically. It seemed like the future had finally arrived for commuters. So why aren't we riding hover trains today? Tragedy and politics. The project faced intense competition from the steel-wheel TGV system, which didn't require building miles of new, ugly concrete tracks elevated above the landscape. After Jean Bertin passed away, the government pulled the funding and canceled the project. Today, all that remains are decaying concrete tracks in the forest, ghostly reminders of a technological marvel that almost changed the world but lost the battle to conventional rail. Let's slow things down and talk about money. A lot of money. This is the train suite Shikishima, operated by JR East in Japan, and it is widely considered the most luxurious train on the planet. Designed by Ken Okuyama, the same man who designed the Ferrari Enzo, this train is a rolling piece of art. The exterior is painted in a custom champagne gold, and the windows are cut in geometric shapes to mimic the organic forms of trees found in nature. Inside, it is not a train, it is a palace. The Shikishima features split-level suites, traditional Japanese bathtubs made of aromatic cypress wood, and a dining car where Michelin-starred chefs prepare your meals right in front of you. The most stunning features are the observatory cars at the front and back. They have futuristic glass walls and ceilings, giving you a panoramic view of the passing Japanese landscape while you sip on vintage wine next to a fireplace. But here is the catch. Getting a ticket is harder than winning the lottery. Trips can cost upwards of $10,000 per person, and demand is so high that you often have to apply through a lottery system just for the chance to buy a ticket. It is an exclusive club on rails, redefining what it means to travel. It's not about the destination, it's about living in a golden dream for 3 days. It is truly the pinnacle of rail travel. If you are afraid of heights, look away now. This is the Pilatusbahn in Switzerland, the steepest cogwheel railway in the entire world. It climbs the glorious Mount Pilatus with a maximum gradient of 48%. That is insanely steep. Normal trains rely on friction between steel wheels and steel rails, but at this angle, a normal train would just slide backward down the mountain into a fiery crash. It requires specialized engineering just to stay attached to the earth. To conquer this mountain, engineer Edward Locher invented a unique system in 1889 that is still used today. Instead of the standard vertical cogs used on other mountain trains, the Pilatusbahn uses 2 horizontal cogwheels that bite into a central rail from both sides. This ensures that the train literally cannot jump off the track, even in high winds or extreme angles. It is a brilliant piece of 19th century engineering that is remarkably safer than driving your car. The journey takes about 30 minutes to ascend over 5,000 feet. As you climb, you pass through alpine meadows, strike through rock tunnels, and eventually break through the clouds. The view from the top, overlooking Lake Lucerne, is worth every second of the anxiety you might feel on the way up. It is a testament to Swiss precision and the human desire to conquer every peak, no matter how impossible it seems. It's an adrenaline rush in slow motion. In Germany, they decided that rails on the ground were too mainstream. Enter the Wuppertal-Schwebebahn, the world's oldest electric elevated railway with hanging cars. Opened in 1901, yes, over 120 years ago, this train hangs from a massive steel frame and runs directly over the Wupper River. It looks like a monorail turned upside down, and it gives passengers the unique sensation of flying through the city streets. It was a steampunk vision that actually came to life. The most famous story about this train involves Tufi, a young elephant. In 1950, a circus director brought Tufi on the train for a publicity stunt. The elephant panicked due to the swaying motion, broke through the side of the car, and fell 40 feet into the river below. Miraculously, Tufi survived with just a few minor scrapes. It is probably the only train crash in history involving a flying elephant, making it a legendary local tale. Today, the fleet has been modernized with sleek, glass-heavy cars, but the experience remains the same. As the train swings gently around corners, you get a bird's-eye view of the streets and water below. It carries over 80,000 people a day, proving that this bizarre hanging bus isn't just a gimmick. It is a vital, living part of German history that refuses to stay grounded. It is undoubtedly one of the coolest public transit systems ever built. Finally, we end our journey with the most famous train in pop culture history. You might know it as the Hogwarts Express, but in reality it is the Jacobite steam train in Scotland. Every year, thousands of fans flock to the West Highlands just to see this magnificent steam engine chug across the Glenfinnan Viaduct, recreating that iconic shot from the Harry Potter movies. But make no mistake, this train is so much more than just a film set. Running a 42-mile route between Fort William and Mallaig, making for an 84-mile round trip, this journey is often voted the greatest railway journey in the world. You are pulled by a vintage Black 5 steam locomotive, smelling the coal smoke and hearing the rhythmic chug of the pistons. It passes by the deepest freshwater loch in Britain, Loch Morar, and the shortest river, River Morar. It is a time machine taking you back to the Golden Age. The engineering here isn't about futuristic magnets or jet engines. It's about the raw power of steam and fire that built the modern world. Watching the Jacobite curve around the viaduct against the backdrop of the Scottish Highlands is breathtaking. It reminds us that sometimes the old ways of doing things are still the most magical. Whether you are a wizard or a muggle, this ride is pure enchantment and a perfect way to end our list. We just went from American jet engines and Japanese luxury to German hanging trains and Scottish magic. The world of trains is way crazier than just getting from point A to point B. Which one would you buy a ticket for? The raw speed of the Shanghai Maglev or the terrifying height of the Pilatusbahn? Let me know in the comments below. If you enjoyed this ride, smash that like button and subscribe. Thanks for watching and see you on the next track. Have you ever seen a steam engine so massive it literally destroyed every track it touched? Or a locomotive designed to recycle its own exhaust because it operated in a desert with zero water? Today we are uncovering the most insane engineering beasts in history, from the Soviet giant that became a total disaster to the American legend that weighs 1.2 million pounds. We are counting down 10 mechanical monsters that defy physics. Stick around for number 8, a train so long it couldn't even turn a corner. Hit subscribe, buckle up, and let's unleash the beasts. We begin our journey in the harsh, unforgiving landscapes of the South African Karoo Desert. Here water is more precious than gold, and standard steam engines simply couldn't survive. Enter the South African Railways Class 25, a machine born from desperate necessity. At first glance, it looks like a classic steam giant, but look closely at the tender trailing behind it. That isn't just a coal wagon, it is a massive, complex condensing plant on wheels. This bizarre spaceship attachment houses enormous turbine fans that give the locomotive a distinct howling sound, unlike the rhythmic chug of a normal train. The engineering behind this monster is pure genius. In a regular steam locomotive, used steam is blasted out of the chimney, wasting thousands of gallons of water into the atmosphere. The Class 25 captured that exhaust, piped it back into the tender, and passed it through huge radiators. These fans cooled the steam, turning it back into liquid water to be pumped right back into the boiler. This closed-loop system allowed the Class 25 to travel up to 500 miles without stopping for water, a feat impossible for any other steam engine of its time. However, operating a recycling plant at 60 miles per hour came with consequences. The complexity was a nightmare for mechanics. Oil and grease would often mix with the condensed water, creating a sludge that damaged the boiler tubes. The turbine fans roared like jet engines, creating a haunting noise that echoed for miles across the empty desert. While most were eventually converted to standard non-condensing engines once diesel took over, the original Class 25 remains a monument to human ingenuity, proving we can engineer our way out of even the driest environments on Earth. Fast-forwarding to the 21st century, we meet a German masterpiece of efficiency that refuses to be categorized, the Siemens Vectron dual mode. For decades, railway operators faced a frustrating gap. Electric trains are powerful and clean but become useless dead weight the moment the overhead wires end. Diesel trains can go anywhere but are noisy and polluting under wires. The Vectron dual mode is the monstrous solution that says, "I'll take both." It is a shapeshifter designed to bridge the gap between electrified main lines and the non-electrified last mile into industrial sidings. Don't let its sleek modern aesthetic fool you. This is a heavyweight freight hauler. Weighing in at 90 tons, it packs a 2,400 kilowatt punch. The magic happens in the transition. Without stopping the train, the driver can drop the pantograph and fire up a massive onboard diesel engine, seamlessly switching power sources. It eliminates the costly and time-consuming need to switch locomotives at rail yards. It is the ultimate logistical weapon, ensuring that heavy cargo keeps moving regardless of the infrastructure above it. This machine represents the future of monster engineering, not just raw size, but monstrous adaptability. The modular design allows parts like the front nose to be easily replaced if damaged, minimizing downtime. While it lacks the smoke and fire of the steam era, the Vectron dual mode commands respect through its silence and reliability. It creates massive tractive effort to pull heavy freight trains across Europe's fragmented rail network. It is a silent predator, conquering borders and systems with a cold, calculated German efficiency that older locomotives could only dream of achieving. In the mid-1990s, a horsepower war erupted on American railroads. Railroad companies wanted to pull heavier trains with fewer engines, and General Electric answered with a nuclear option, the AC6000CW. This wasn't just an upgrade, it was a leap into insanity. With a staggering 6,000 horsepower crammed into a single frame, it was designed to replace two standard 3,000 horsepower locomotives. Standing next to one, you feel the ground vibrate. It is a towering block of American steel, instantly recognizable by its massive rear radiators that flare out like wings over the walkway. The heart of this beast is the 7HDL16 engine, a power plant co-developed with German engineers that pushed the limits of diesel technology. The goal was to haul massive coal drags over the Rocky Mountains without needing helper engines. When an AC6000CW throttles up to notch 8, the sound is deafening, a deep guttural roar that signals raw, unadulterated power. It was the absolute peak of the bigger is better philosophy that has defined American railroading for a century. But being a pioneer is dangerous. The sheer power of the AC6000CW literally tore the engine apart in the early days. The vibrations were so intense they caused cracks in the engine block and turbocharger failures. It was a monster that was difficult to tame. General Electric had to spend years refining the design to make it reliable. Today, while many have been derated or retired, the AC6000CW remains a legend. It stands as a testament to a time when engineers looked at the laws of physics and decided to punch a 6,000 horsepower hole right through them. History often remembers the Big Boy as the largest steam locomotive, but the Chesapeake & Ohio's Class H8 Allegheny has a legitimate claim to the throne. Built by the Lima Locomotive Works in the 1940s, the Allegheny was a 2666 articulated Titan designed for one specific brutal job: dragging coal trains over the steep grades of the Allegheny Mountains. While the Big Boy was built for distance and speed, the H8 was built for pure bone-crushing muscle. It is widely considered by experts to be the heaviest reciprocating steam locomotive ever built in terms of engine weight. The statistics of the H8 are mind-bending. Its firebox was so cavernous, capable of burning 8 tons of coal per hour, that a standard shovel was useless. It required a mechanical stoker just to keep the fire fed. In dynamometer tests, the Allegheny produced nearly 7,500 horsepower, a figure that actually exceeds the Big Boy's output. It was a boiler on wheels that could generate steam faster than the cylinders could use it. The boiler was so immense that the safety valves would scream like banshees when they popped, terrifying anyone nearby. The H8 was a monster of excess. It was so heavy that it damaged the rails if not operated carefully. It could haul 10,000-ton coal trains single-handedly, replacing 2 or 3 lesser engines. Sadly, the railroad often misused them, running them at slow speeds where their massive horsepower couldn't be fully utilized. Only 2 of these magnificent giants survived the scrapper's torch. The Allegheny remains the bodybuilder of the steam era, a machine of such exaggerated proportions and power that it seems almost cartoonish in its strength. In the vast expanse of China, connecting billions of people requires a machine with incredible endurance. Meet the DF11G, the pride of the China Railway Speed Up campaign. It operates as a pair, joined permanently to create a seamless powerhouse. The G stands for modified, and this beast was built for the humid heat of Hong Kong without refueling. Inside, it houses 2 16 V280ZJA engines that can sustain speeds of 100 miles per hour for 24 hours straight. What makes the DF11G a monster is its reliability under extreme pressure. It served as the backbone of China's passenger transport during the critical years before high-speed rail took over. Even today, in emergencies or on non-electrified lines, the DF-11G is the machine they call. Deep inside the Arctic Circle, on the border of Sweden and Norway, operates a train that eats other trains for breakfast. This is the Bombardier EORA. Most locomotives are built for speed or mixed cargo. The EORA was built for one thing: moving mountains of iron ore. It consists of two identical electric sections coupled together to form a single unit that produces a terrifying 14,000 horsepower. With a tractive effort of 1,200 kilonewtons, it is officially one of the most powerful locomotives on the planet. The operating conditions here are lethal. Temperatures drop to 40 degrees, and the tracks are covered in ice. Standard steel becomes brittle and snaps, but the IORE is built like a tank. It hauls trains weighing up to 8,600 metric tons, that's nearly 19 million pounds, down from the mines to the port. Here is the crazy part. Because the route is mostly downhill towards the coast, the IORA uses its massive electric motors as generators. It uses regenerative braking to hold the heavy train back, generating so much electricity that it actually powers the empty trains going back up the hill. Everything about the IOR is heavy-duty. The axle load is a crushing 30 tons, requiring specially reinforced tracks. If a normal train tried to drive on these rails, it would look like a toy. The couplers are made of high-strength steel to prevent the train from snapping in half under its own weight. The IORE is a silent, freezing monster, a testament to how extreme engineering is required to extract resources from the most hostile corners of the Earth. The 1939 World's Fair in New York promised a world of tomorrow, and the Pennsylvania Railroad unveiled their vision of the future, the Class S1. Styled by the legendary industrial designer Raymond Loewy, the S1 was a masterpiece of Art Deco design. It looked like a bullet, streamlined and futuristic. But underneath that beautiful shell was a mechanical Frankenstein. It utilized a unique duplex drive system with a 6-4-4-6 wheel arrangement. It was the longest rigid-frame locomotive ever built, stretching an incredible 140 feet. However, the S1 was a classic case of form over function. It was simply too big. The locomotive was so long that it couldn't navigate the tighter curves of the rail network, severely limiting where it could go. Worse, the weight distribution was flawed. Most of the weight rested on the pilot trucks rather than the driving wheels. This meant the S1 was prone to terrible wheel slip. When starting a heavy train, the wheels would spin helplessly on the rails, grinding steel against steel while the train went nowhere. Despite rumors that it once exceeded 150 miles per hour to make up time, the S1 was a maintenance nightmare. It spent more time in the repair shop than on the tracks. The sheer length meant it often derailed in the yards. After only a few years of service, this beautiful monster was quietly scrapped. The S1 serves as a valuable history lesson. Engineering limits exist for a reason. It was a glorious, expensive failure, a dinosaur that was too big to survive in a changing world. If the S1 was a mistake, the Soviet AA-21 was a catastrophe. In the 1930s, Soviet planners wanted to showcase their industrial superiority to the world. Their solution? Build the locomotive with the most driving wheels in history. The AA-20 featured a 4-14-4 wheel arrangement. Yes, you heard that right. 7 driving axles all fixed in a single rigid frame. It was a beast designed to haul massive coal trains in the Donbass region, but the designers ignored basic geometry. When the AA-21 finally hit the tracks, disaster struck immediately. The locomotive was so long and stiff that it couldn't go around curves. Instead of turning, the massive force of the wheels simply pushed the rails apart, widening the track gauge and causing the train to derail. It destroyed the switches and points in every rail yard it entered. It was a track-wrecking machine. Additionally, it was too heavy for existing bridges and too long for the turntables, meaning once it reached its destination, it couldn't turn around to come back. The AA-21 made only a single promotional trip before the engineers realized they had built a useless monster. It was quietly parked on a siding and eventually scrapped, and its existence was hushed up to avoid embarrassment. It stands as the ultimate example of engineering hubris. It proved that you cannot simply add more wheels to a problem and hope it works. The AA-21 remains a mysterious metallic ghost of the Soviet era. In 1969, the Union Pacific Railroad celebrated its 100th anniversary, and they wanted a gift for themselves. They went to Electromotive Diesel, EMD, and asked for the biggest, baddest diesel locomotive ever made. The result was the DDA-40X, fittingly nicknamed the Centennial. At 98 feet long, it remains the longest single-unit diesel locomotive in history. It is so large that it essentially consists of two huge diesel engines mounted on a single chassis, producing a combined 6,600 horsepower. The X in its name stood for experimental, and this machine was a rolling laboratory. It pioneered the modular electronic systems that are standard in trains today, but for the crews it was all about the ride. The DDA-40X was fast, capable of hauling freight at 90 miles per hour. Its massive length and weight gave it an incredibly smooth ride, gliding over the tracks like a luxury liner. The distinctive wide nose cab became a symbol of safety and comfort for the engineers. Only 47 of these land yachts were ever built, and they dominated the American West for over a decade. Seeing a Centennial thunder across the Nebraska plains was a sight to behold. They were retired as fuel efficiency became more important than raw power, but one, number 6936, was kept in service for decades as a heritage unit. The DDA-40X is the peak of the big diesel era, a reminder of a time when Union Pacific's philosophy was simply to build the biggest thing on rails and get out of the way. And finally, we arrive at the king, the undisputed heavyweight champion of the world, the Union Pacific Big Boy. Coded as the 4884, this articulated giant was born in 1941 with a singular purpose: to conquer the Wasatch Mountains without needing help. It is 132 feet long and weighs 1.2 million pounds. To put that in perspective, that is heavier than 3 Boeing 747s combined. It is not just a train, it is a moving fortress of steel, fire, and steam. The Big Boy is a marvel of articulation. The front set of driving wheels can swing independently, allowing this massive beast to navigate curves that would derail smaller, rigid locomotives. It consumed 28 tons of coal and 24,000 gallons of water, requiring a massive centipede tender just to keep it fed. During World War II, these monsters were critical to the Allied war effort, hauling millions of tons of supplies across the continent. Unlike the flawed designs we saw earlier, the Big Boy worked perfectly right out of the box. For 60 years, we thought they were gone, silent museum pieces. But in 2019, Union Pacific performed a miracle. They restored Big Boy number 4014 to fully operational condition. Watching it run today is a spiritual experience. The ground shakes, the heat hits your face, and the whistle screams with a voice from the past. It is the only operating machine of its size in the world. The Big Boy isn't just a locomotive, it is the ultimate mechanical proof of American industrial ambition. From the water recycling Class 25 to the track-destroying Soviet AA-20, these 10 monsters pushed the limits of what humans could build. They were loud, heavy, and absolutely magnificent. Which one is your favorite? I'm sticking with the Big Boy, but let me know yours in the comments. If you enjoyed this heavy metal history, smash that like button and subscribe for more engineering insanity. Thanks for watching, and I'll see you on the next track. Forget the conventional war machines. Throughout the great conflicts, the world's biggest logistical assets and weapons moved on iron tracks, often hidden from historical view. They are the colossal armored locomotives and railguns of unmatched destructive power, engineered to change the outcome of war with a single journey. We are unlocking the files on these 10 steel giants, from ingeniously built resistance trains to the planet's largest 800mm rail cannon. These machines were arguably too massive, too ambitious to exist. Stick with us until the end to witness the proof. If you are fascinated by history and engineering, hit subscribe now and tell us, what do you believe caused these machines to be forgotten? In the chaos of 1944, as the Slovak national uprising ignited against Nazi occupation, the rail workers of Zvolen couldn't wait for outside help. They built their own. The Stefanik armored locomotive is a testament not to state-funded military might, but to raw, patriotic ingenuity. This wasn't a sleek military design, it was an act of defiance, forged from a standard steam locomotive and whatever steel plating the workshops could find. Its primary purpose was to transport troops and supplies, but its armored carriages were outfitted with machine guns and even salvaged anti-tank cannons. Its design was fundamentally makeshift but strategically brilliant. The crew stripped down obsolete machinery, welding heavy armor plates directly onto the locomotive's frame and the attached wagons. Crucially, its firepower was often enhanced by repurposing parts from disabled tanks. The Stefanik was a moving fortress, crucial in keeping supply lines open and engaging in direct skirmishes against German forces attempting to crush the uprising. Its very existence boosted the morale of the resistance and proved that the workers' resolve could literally be forged into a weapon. The sheer audacity of this project makes it historically significant. It participated in several crucial battles, acting as mobile artillery support in areas where heavy equipment was otherwise impossible to deploy quickly. Though eventually captured and destroyed, the Stefanik embodies the fierce, spontaneous nature of partisan warfare. Its legacy is a stark reminder that sometimes the most effective military machines are not those conceived in high-tech labs, but those born out of necessity and courage. Fast forward 5 decades to the 1990s, and the concept of the improvised armored train was violently resurrected during the brutal Yugoslav wars. Meet the Hrvatski oklopni vlak, which literally translates to Croatian armored train. This wasn't a WP relic, it was a brutal modern-day combat vehicle. Built and operated by the Croatian army, this machine was purpose-built to survive the intense localized conflicts that tore through the Balkans. Its history is a chilling look at how easily conventional warfare can devolve into something far more brutal. The Hrvatski oklopni vlak was essentially a heavily modified diesel-electric locomotive and a series of purpose-built wagons. The armor plating was thick, designed to withstand machine gun fire and even heavier rounds. Unlike the Stefanik, this machine was built with significant firepower from the start, often mounting anti-aircraft cannons and heavy machine guns, primarily used for convoy protection, troop movement, and direct fire suppression against static enemy positions. Its operational zones were often the most dangerous front lines, making it a critical asset in the conflict. The most striking feature was its psychological impact. The sight and sound of a heavily armored train appearing on the railway line, spewing fire and smoke, was often enough to break enemy morale. While conventional forces struggled with road ambushes and treacherous terrain, the train utilized the fixed network of rails, giving it speed and tactical mobility unavailable to tanks. The Hrvatski oklopni vlak serves as a modern military paradox, a throwback technology that proved terrifyingly effective in a contemporary war zone. The uprising at Zvolen was a two-train operation, and the Hrban armored train was the powerful companion to the Stefanik. While often overshadowed by its sibling, the Hrban was arguably the better-armed and more structurally sophisticated of the two, representing the absolute peak of the Slovak resistance's rail ingenuity. It was named after a key figure in Slovak history, solidifying its role as a symbol of national fight. Together, these two trains were the heavy cavalry of the 1944 resistance. The Hrban structural design incorporated a standard locomotive that was meticulously shrouded in thick armor. Where the Stefanik was more of a mobile barricade, the Hrban was a dedicated assault platform. It was notably equipped with a formidable collection of repurposed weaponry, including a captured 75mm anti-tank gun mounted in a turret, giving it far greater long-range hitting power against German tanks and bunkers. This superior armament allowed it to perform more aggressive combat maneuvers and act as the spearhead in several key engagements. Its operational life was short but heroic. The Herben was instrumental in holding strategic railway junctions and providing fire support during the desperate fighting in central Slovakia. The level of detail and quality of the welding, given the circumstances of its construction, under constant threat of German aerial reconnaissance and attack, is astounding. The Herben ultimately fell victim to the overwhelming German counteroffensive, but its design influence and battlefield success cemented the armored train's place in the history of asymmetrical warfare. The rail warfare resurgence of the 1990s wasn't limited to the Croatians. In the self-declared Republic of Serbian Krajina, the Serbs utilized their own terrifying rail monster, the Krajina Express. This machine was one of the largest and most heavily armed improvised armored trains of the entire Yugoslav conflict, a true symbol of the intense, localized engineering effort to gain military advantage on the fixed railway network. Its construction took place in the main railway workshops in Kanin, the capital of the Krajina region. Unlike the smaller, more agile armored rail cars, the Krajina Express was a massive, intimidating beast. It incorporated a diesel-electric locomotive and a number of freight wagons completely encased in thick, often crude but effective armor plating. Its arsenal was truly immense, frequently featuring multiple anti-aircraft cannons, heavy machine guns, and at various times, even rocket launchers stripped from other vehicles. This gave it a dual role, not just defense and transport, but a potent surprise offensive weapon capable of delivering massive suppressing fire. To understand the true scale of the German war machine, you must look beyond the tanks and aircraft and recognize the Class 52. This wasn't an armored combatant, but the most massive and ubiquitous logistical giant of the Eastern Front. The ultimate Kriegslokomotive, or war locomotive. Its size is measured not in armor thickness, but in production numbers and sheer capacity to haul. Without the Class 52, the entire German operation in the East would have ground to a frozen, catastrophic halt. Designed and mass-produced by the thousands, the Class 52 was a marvel of minimalist engineering. The primary goal was rapid, cheap construction using minimal strategic materials, while retaining the power needed to operate in the brutal sub-zero conditions of the Soviet Union. Every non-essential feature was stripped away, resulting in a robust, standardized design that could be manufactured across multiple occupied territories simultaneously. Its streamlined production made it one of the most numerically successful steam locomotives of all time. The Class 52's true size is logistical. It was the absolute workhorse, hauling the vast majority of troops, ammunition, supplies, and fuel needed to keep the enormous, sprawling Eastern Front operation running. Its standardized parts and reliable design meant it could be quickly repaired, even in the field. After the war, thousands of these locomotives continued to serve civilian railways across Europe for decades, a testament to their rugged, essential design. The Class 52 proves that the biggest military impact is often achieved not by the heaviest gun, but by the most reliable means of transport. Not all rail weapons were colossal trains. Some were fast, specialized armored rail cars. The Panzertriebwagen 16, or Armored Motor Car 16, was one of the most advanced rail combat vehicles developed by Germany during World War II. It represents a different philosophy of rail warfare, not brute force and logistics, but speed, internal security, and rapid response. This motorized vehicle was sleek, heavily armored, and designed to move where a full armored train could not. The Panzertriebwagen 16 was a self-propelled, diesel-powered vehicle, allowing it to operate independently of a separate locomotive. This gave it a significant advantage in response time and mission versatility. Its armament was typically housed in turrets mounted on top of the car, often including light cannons or heavy machine guns. The Panzertriebwagen 16 highlights the transition from massive, complex train sets to more agile, specialized fighting units. From the Soviet Union comes the MBV-2, a machine that combines the best features of an armored train and a rail car into a singular, formidable fighting unit. The MBV-2, which stands for Motorized Armored Wagon, was essentially a self-propelled armored carriage designed for frontline operations and tactical support. It was a heavyweight in its own right, demonstrating the Soviet commitment to utilizing the vast rail network as a primary platform for heavy combat support. What made the MBV-2 a giant was its incredible firepower packed into a single car. This wasn't just a transport, it was a land battleship on rails. Its most iconic configuration featured not one but three complete T-28 tank turrets mounted on its roof. Each turret was equipped with a 76.2 mm cannon, giving the car the offensive punch of three medium tanks simultaneously, a truly massive concentration of firepower for a single rail vehicle. The car also carried multiple machine guns for anti-infantry defense. The MBV-2 was heavily used during the early stages of World War II, particularly in the defense of strategic points and the clearing of railways from enemy incursions. Its heavy armor ensured its survival against most field artillery of the time, and its ability to rapidly deploy powerful cannon fire made it an invaluable asset. Like its German counterpart, the MBV-2 represented a mature design philosophy for specialized rail combat vehicles, but on a distinctly larger and more heavily armed scale, embodying the Soviet preference for overwhelming defensive and offensive capacity. When we talk about biggest locomotives, the Soviet AA-20-1 deserves a place as a giant of raw industrial scale. Though not inherently a combat machine, its existence speaks to a monumental military and industrial ambition that underpinned the Soviet war effort. The AA-20-1 holds the distinction of being the largest and most powerful non-articulated steam locomotive ever built, designed for high-speed, heavy load hauling across the Soviet Union's immense and strategically vital rail system. The sheer size of the AA-21 is best understood through its legendary wheel arrangement, 4-14-4. No other non-articulated locomotive has ever been built with a 14-coupled driving wheel system. Its purpose was to haul exceptionally heavy freight and passenger trains at high speeds, dramatically reducing transit times for vital resources. This experimental giant was a declaration of the Soviet desire to build the fastest, strongest locomotives in the world, essential for a nation that relied so heavily on rail logistics for national defense and development. Unfortunately, its size was also its ultimate flaw. While technologically magnificent, the immense rigidity of its 14 coupled wheels caused severe damage to the existing, often poor quality, Soviet rail infrastructure. Despite its failure to enter mass production, the single prototype that was built remains a stunning testament to the Soviet industrial scale. The AA-21 is a true industrial titan, a behemoth that exceeded the capacity of the infrastructure it was meant to serve, and a compelling entry in the list of the largest rail machines. Transitioning from armored trains to pure concentrated artillery, we arrive at the Krupp K5, often known by its gun names, Leopold and Robert. This was Germany's premier heavy railgun of World War II, a stunning combination of engineering elegance and destructive power. It was the largest rail cannon put into widespread active service, capable of hurling a 283-meter shell dozens of miles with terrifying accuracy. The K5 was the definition of rail-based strategic heavy artillery. The K5 gun and its carriage weighed a colossal 120 tons, a weight that required the stable and massive platform of the railway system. Unlike earlier, more static heavy artillery, the K5 was designed for operational mobility. It could be rapidly moved to different sectors of the front line, providing long-range bombardment against targets that conventional artillery could never reach, such as fortified coastal positions or strategic bridges deep behind enemy lines. This mobility made it a constant threat. Its most famous action was the bombardment of the Allied beachhead at Anzio, Italy, where the Leopold and Robert, the two guns involved, rained down huge shells on the American and British forces, earning them a fearsome reputation. The complexity of its operation, requiring specialized rail lines, vast crews, and dedicated locomotives for transport, only underscores its scale. The Krupp K5 was a masterful piece of engineering that proved the strategic value of massive rail-mobile artillery in the age of modern warfare. And now the undisputed heavyweight champion, the machine that redefines the very word biggest. This is the Schwerer Gustav, or its sister gun, Dora, the largest caliber rifled weapon ever used in combat, and the largest mobile railgun in history. When we talk about military giants on rails, every other machine is merely a prelude to the overwhelming catastrophic scale of the Schwerer Gustav. Its statistics defy belief. The gun fired an 800mm shell, a projectile that weighed 7 tons. The entire railgun assembly weighed a mind-boggling 1 to 350 tons and required 2 parallel sets of railway tracks for stability. Its operational requirements were astronomical, needing a dedicated crew of around 2,500 men for assembly, maintenance, and firing. The Schwerer Gustav saw its only combat use during the Siege of Sevastopol in 1942, where its 800mm rounds were able to penetrate up to 30 meters of reinforced concrete to destroy deep underground Soviet fortifications. Its size was not just a symbol, it was functional, capable of delivering destruction that no other land weapon could match. Though its combat service was extremely limited due to its complexity and vulnerability, the Schwerer Gustav remains the absolute apex of rail-based military hyperscale, a definitive, terrifying monument to industrial ambition run wild. From the improvised, courageous resistance of the Stefanik and Herben trains, to the logistical dominance of the Class 52, and finally to the terrifying absolute scale of the 350-ton Schwerer Gustav railgun, the history of the biggest military trains is a story of forgotten innovation and colossal power. They prove that in the annals of warfare, the railway was the ultimate unsung strategic highway. Which of these steel titans do you believe history failed to properly recognize? Let us know in the comments. And if this journey into the hidden history of rail warfare excited you, do not forget to like this video and subscribe to our channel for more deep dives into the machines that truly shape the world. Forget about today's quiet, smooth bullet trains. We are talking about 1 million pound steel monsters that breathed fire and literally shook the earth. Today we aren't just listing trains, we are waking up legends. We are diving deep into the lost blueprints and incredible stories of survival that time almost forgot. I have hunted down the 10 most rare, powerful, and physically impossible steam locomotives ever built by human hands. But be warned, you need to stay until the very last second because the locomotive at number 10 holds the most controversial secret in history, a phantom speed record that many claim was covered up. Is it real? Smash that subscribe button right now so you don't miss the answer, and let's unleash the beasts. We begin our journey in the United Kingdom with the Great Western Railway 47-3, widely known as the Castle class. When the first of these, the Caerphilly Castle, rolled out in 1923, it was a direct challenge to every other railway. Designed by Charles Collett, this 460 locomotive wasn't just an upgrade. It was a revolution, claiming to be the most powerful express passenger locomotive in Britain, with a tractive effort of 31,625 pounds. This figure shocked the industry. Its design featured a high-pressure boiler and 4 cylinders, making it perfectly suited for hauling heavy holiday express trains to the West Country with incredible reliability. The true legend of the Castle class was cemented during the famous 1925 locomotive exchange. The GWR pitted their Castle against the Elner's much larger Pacific-type engines. On paper, the massive Elner giant should have won easily, but in practice, the compact Castle class shocked the engineering world. It burned significantly less coal and maintained speed better on steep gradients, proving that efficiency and precision engineering were superior to sheer size. The Castle's 4-cylinder arrangement provided an incredibly smooth ride, and this victory forced rival railways to completely redesign their own locomotives to match the efficiency of the Castle. Today, the specific unit Caerphilly Castle is a celebrated icon of British heritage. After clocking nearly 2 million miles in active service, it was retired in 1960. Instead of being cut up for scrap metal like thousands of others, it became a crown jewel of the National Railway Museum's collection. Technically, it operated with a boiler pressure of 225 psi, a bold move for the early 1920s, allowed for rapid acceleration. Enthusiasts love the Castle class not for being the biggest, but for being arguably the most aesthetically pleasing British engine ever built, representing a golden age of steam elegance. If the Castle class was about elegance, the LMS Coronation class was about raw, futuristic speed. Built in 1937 at the height of the Streamline era, the 6020 Coronation looked less like a train and more like a rocket ship. Designed by Sir William Stanier, these Pacific 4-62 locomotives were built to haul the prestigious Coronation Scots service between London and Glasgow. The locomotive was encased in a steel aerodynamic shell, painted in a stunning Caledonian blue with silver stripes. This wasn't just for show, to reduce air resistance at high speeds, allowing the train to cut through the air. The 6220 is famous for its trip across the Atlantic in 1939, where it was shipped to the United States for the New York World's Fair. To run legally on American rails, it was fitted with a bell and a strong headlight, features not typically used in Britain, giving it a unique hybrid look that American rail fans still talk about today. It toured the eastern U.S., running alongside American giants and holding its own. Just before this tour, on a test run, it briefly hit a top speed of 114 miles per hour, snatching the British speed record and proving its capability. Beneath the streamlined casing lay a beast producing over 3,300 horsepower, making it the most powerful steam passenger locomotive ever built for the British railway network. One of its secrets was the specific tender design that allowed it to scoop water from troughs between the tracks while moving at speed, eliminating the need for frequent stops. Although the beautiful streamlining was eventually removed during World War II to make maintenance easier, the legacy of the Coronation class remains. It stands as a monument to the fierce competition of the 1930s, pushing steam technology to its absolute zenith before the war. Now we look at American perfection, the Norfolk and Western 611. This is a Class J 484 locomotive, and many experts consider it the finest passenger steam engine ever built. Unlike most railroads that bought their engines from commercial builders, the Norfolk and Western built the 611 in-house at their own shops in Roanoke, Virginia. This gave them total quality control. Completed in 1950, very late in the steam era, the 611 incorporated every modern technology available, including Timken roller bearings on all axles and moving parts. This reduced friction so effectively that a few men could theoretically push the 450-ton engine on level track. The N&W operated in the treacherous Blue Ridge Mountains, requiring an engine that had both high tractive effort for grades and high speed for the flats. The 611 was the answer. Despite having relatively small 70-inch driving wheels, the counterbalancing on the wheels was so precise that the 611 could comfortably cruise at 110 miles per hour. The bullet nose streamlining was iconic, designed not just for speed but to look powerful. It ran on Pocahontas coal, considered the best in the world, which allowed the N&W to stick with steam power long after other railroads had switched to diesel. The 611 is the only survivor of the 14 Class J locomotives built. Its survival is a miracle. After retirement in 1959, it was saved from the scrapper's torch and has since become the most famous excursion locomotive in America. It has been restored twice, most recently in 2015, and draws crowds of thousands wherever it goes. When you hear the 611's deep, mournful steamboat whistle echoing through the valley, you are hearing the heartbeat of industrial America. It is a mechanical celebrity, representing the pinnacle of steam development, powerful, reliable, and incredibly beautiful to watch in motion. Let's venture into rare territory with the Hungarian State Railways MAV Class 242. This is a machine that often flies under the radar of U.S. enthusiasts, but it is an engineering marvel. Built between 1936 and 1939, the Class 242 is a 444 tank locomotive. This Baltic wheel arrangement is extremely rare for high-speed engines. It was designed specifically for the flat plains of Hungary, where the railway needed a lightweight, fast engine to connect major cities. The entire locomotive was covered in a full aerodynamic shroud, similar to the British Mallard, giving it a sinister bat-like appearance. The streamlining on the 242 wasn't just cosmetic, it was the result of extensive wind tunnel testing. The engineers managed to reduce air resistance by nearly 30% compared to standard engines. This efficiency allowed the relatively small engine to punch way above its weight class. In 1961, the sister engine of the one we see today set a national speed record of exactly 100 miles per hour, 161 km/h. Achieving this speed with a tank engine, where water and coal are carried on the locomotive frame itself, was a significant technical achievement, proving Eastern European engineering was world-class. Only 4 of these unique machines were ever built. They survived the devastation of World War II and served well into the Cold War era. Today, only one remains, the 242P01, preserved in Budapest. It is occasionally fired up for nostalgia trips, where it still manages to turn heads with its unusual shape and coffin nose front. It stands as a testament to the global nature of the streamline craze of the 1930s, showing that the desire to go faster and look sleeker was a universal language among engineers, regardless of which side of the Iron Curtain they were on. Before the big boy stole the spotlight, the Union Pacific Challenger was the king of the rails. The 3985 is a 4-664 articulated locomotive built by Alco in 1943. Articulated means the frame is hinged in the middle, allowing this massive engine to bend around curves that would derail a rigid frame locomotive. Designed as a dual-service engine, it had the raw power to haul heavy freight trains up the Wasatch Mountains, but it also had the speed to pull passenger trains at 70 mph. It was the Goldilocks engine, big enough to do the hard work but fast enough to keep the schedule. What makes the 3985 legendary is its second life. After being retired in the late 1950s, it sat on display until 1981, when a group of Union Pacific employees volunteered their own time to restore it. For nearly 30 years, the 3985 was the world's largest operating steam locomotive, a title it held until 2019. It became an ambassador for the railroad, pulling excursion trains all over the United States. Unlike the coal-fired big boy, originally, the 3985 was converted to burn oil early in its excursion career, which made it easier to operate and cleaner, preventing trackside fires. Watching the 3985 in action was a visceral experience. It generated nearly 97,000 pounds of tractive effort. When it launched a heavy train, the ground would literally shake. The sight of the 2 independent sets of driving wheels slipping in and out of sync created a unique visual and auditory rhythm that mesmerized fans. Although currently retired and recently donated to the RRHHMA for another potential restoration, the Challenger 3985 remains a legend. It proved that articulated locomotives weren't just slow mountain climbers, they could be fast, agile, and incredibly majestic machines that defined an era. Prepare for the fastest operational steam locomotive in the world, the German DR 18201. This engine is a fascinating anomaly because it wasn't built in the 1930s, it was built in 1961 in East Germany. The Halle Test Center needed a locomotive capable of high speeds to test new passenger coaches for export, but they lacked the funds to design one from scratch. So engineers improvised. They took the high-pressure boiler from an older high-tech train and parts from a Class 45 to build this magnificent Frankenstein machine. The result was a streamlined beauty painted in bright green with red wheels. The defining feature of the DR 18201 is its massive driving wheels. They measure over 7 feet 6 inches, 2.3 meters in diameter. These are among the largest driving wheels ever fitted to a locomotive, allowing for incredible top speeds. In 1972, it reached a record speed of 113.3 miles per hour, 182.4 km/h, making it the fastest steam locomotive currently capable of running. To maintain such power, it uses an oil firing system and a special exhaust chimney to maximize draft and efficiency. It was designed to run fast, and it often outran the diesel engines of its time. Beyond its speed, the DR18201 is equipped with a rig brake system to test other vehicles, effectively making it a rolling laboratory. For decades, it was the pride of the East German railways. Today, it is owned by a private company and is a star attraction at European rail festivals. Seeing the 18201 fly past with its gigantic wheels blurring is a surreal experience for any American used to smaller wheels. It proves that necessity is the mother of invention. Even with limited resources, engineers created a world record holder that is still running today. At number 7 is the Red Devil, formerly known as the South African Railways Class 26. This locomotive represents the ultimate what-if in railway history. In the late 1970s, as the world rushed to switch to diesel, engineer David Wardale believed steam technology still had potential. He took a standard Class 25NC locomotive and completely rebuilt it in 1981 using modern thermodynamics. His goal was to prove that modern steam could compete with diesel in terms of cost. He painted it a fiery, demonic red, signaling its radical departure from tradition and its aggressive performance goals. The secret weapon of the Red Devil was the gas producer combustion system, GPCS. In a normal steam engine, a lot of coal is wasted, blown out of the chimney. The GPCS changed the airflow to burn coal as a gas, drastically improving combustion. Wardale also installed a double exhaust to improve the draft. The results were staggering. The Red Devil used 30% less coal and 40% less water than the original engine, while increasing power output by 43%. It produced over 5,000 horsepower, a figure previously thought impossible for a narrow-gauge locomotive of this size. Despite its incredible success, the Red Devil came too late. The decision to dieselize South Africa had already been made, and the political climate didn't favor steam. The locomotive was eventually retired, and the modern steam movement lost its momentum. However, the data gathered from the Red Devil became the Bible for modern steam engineering. It remains the most technologically advanced steam locomotive ever built, standing as a lonely monument to an alternate future where clean, efficient steam engines continue to rule the rails alongside diesels. You knew it was coming. The Union Pacific Big Boy, specifically the 4884 wheel arrangement. These monsters were built between 1941 and 1940 Pacific task to conquer the steep grades of the Wasatch Mountains in Utah without needing helper engines. Weighing in at 1.2 million pounds, engine and tender, and stretching 132 feet long, the Big Boy is simply massive. It is widely recognized as the largest and heaviest reciprocating steam locomotive ever built. The frame is articulated, but unlike the Challenger, the Big Boy was designed for maximum tractive effort, pulling 4-mile-long freight trains. The numbers on the Big Boy are mind-boggling. It carried 28 tons of coal and 24,000 gallons of water. It consumed fuel so fast that a human fireman couldn't possibly keep up, so it used a mechanical stoker to crush and feed coal into the firebox. It produced 6,290 drawbar horsepower. The engine was so long that the Union Pacific had to rebuild their turntables and engine sheds just to accommodate it. It wasn't just big, it was stable. It could run at 80 mph, though it usually operated closer to 60 mph. It was the ultimate expression of American industrial might. Of the 25 built, 8 survived, mostly in museums. But in 2013, Union Pacific reacquired Big Boy number 4014 and began a multi-year restoration. In May 2019, to celebrate the 150th anniversary of the Transcontinental Railroad, Big Boy 4014 moved under its own power again. It was converted to burn oil for logistical reasons, but seeing this Leviathan thunder across the Midwest today is a spiritual experience for machine lovers. It is a rolling earthquake, a living dinosaur that reminds us of a time when America built the biggest things on Earth. From maximum power to maximum speed. At number 9 is the Eternal World Champion, the Elner class A4-4468 Mallard. Designed by the genius Sir Nigel Gresley, the A4 class was the British answer to the German high-speed diesel trains. They featured a distinctive wedge-shaped streamlined casing tested in wind tunnels, which not only reduced drag but also lifted smoke away from the driver's vision. On July 3, 1938, the Mallard was chosen for a special attempt. The driver, Joe Duddington, and fireman Tommy Bray pushed the engine down Stoke Bank, a slight downhill gradient. The dynamometer car behind the engine recorded the speed climbing 120, 123, 125 until it peaked at 126 miles per hour, 203 kilometers h. That record has stood for over 85 years and will likely never be broken by another steam locomotive. The effort was so intense that the big end bearing on the middle cylinder overheated and melted, forcing the train to limp back to the depot. But the damage didn't matter. The record was secured. The Mallard had proven that steam could travel as fast as the emerging airplanes of the day, securing glory for Great Britain. The Mallard is more than just a record holder. It is a piece of art. Painted in garter blue with red wheels, its design is timeless. While other claimants to the speed record exist, like the PRR S1 we will discuss next, none have the verified data-backed proof that Mallard has. Today, it sits in the National Railway Museum in York, UK. It is revered almost like a religious artifact. It represents the absolute physical limit of steam technology, the moment when man and machine worked in perfect, dangerous harmony to make history. Finally, at number 10, we have the most ambitious and perhaps the most tragic experiment in steam history, the Pennsylvania Railroad S1. Debuting at the 1939 New York World's Fair, this was a 6446 duplex drive locomotive, designed with styling by Raymond Loewy. It was absolutely gigantic, over 140 feet long, making it the longest reciprocating steam locomotive ever, longer even than the Big Boy. It was built to be the ultimate passenger engine, capable of hauling 100 tons at 100 miles per hour. It looked like something from a sci-fi movie, earning it the nickname the Big Engine. The S1 used a unique duplex system with 2 pairs of cylinders driving 2 separate groups of wheels on a single rigid frame. This was meant to reduce piston weight for high speed. However, the S1 was simply too big. Its rigid wheelbase was so long that it couldn't fit on most turntables and constantly derailed on tight curves. Worse, because the 2 sets of wheels weren't connected, one set would often lose traction and spin wildly, wheel slip, forcing the engineer to throttle back. It was a nightmare to operate and maintain, restricted to only a specific straight section of track. Despite its flaws, the S1 was incredibly fast. There are persistent stories and unverified reports of the S1 reaching speeds of 156 miles per hour while trying to make up time, which would shatter the Mallard's record. However, no official documentation exists to prove it. Sadly, the S1 was a victim of its own complexity. By 1949, with diesels taking over, the PRR scrapped this one-of-a-kind giant. Not a single piece was saved. It remains a phantom legend, a testament to American ambition pushing the limits until they finally broke. From the precision of the British Castle class to the earth-shaking power of the Big Boy, from the tragic ambition of the PRR S1 to the eternal speed record of the Mallard, these 10 locomotives aren't just metal, they are the mechanical soul of history. Which one would you resurrect if you could? Was the Red Devil the true future of steam? Let me know below. Hit like and subscribe for more heavy metal legends. Thanks for watching. Forget the diesel workhorses. Today we return to the golden age of rail, when engineers defied every limit of physics and scale. We are not talking about quaint old trains. We are talking about industrial monsters, the largest steam locomotives ever built. These colossal machines unleashed extraordinary power to conquer the world's toughest rail lines. From the massive American Union Pacific Big Boy to the equally fierce Allegheny, we are going to examine exactly which machine truly deserves the crown of power. Subscribe and comment now to join the debate. Let's begin this countdown. The name itself is legendary, Big Boy. This locomotive doesn't just represent American railroading, it defines it. When the Union Pacific needed a solution to haul heavy freight trains over the steep grades of the Wasatch Mountains, they didn't ask for a bigger train, they asked for a monster. And they got the 4884 articulated masterpiece. The Big Boy's colossal scale was a direct response to a massive economic demand. Designed in the 1940s, it boasts an incredible 6,290 horsepower and a total weight with tender of nearly 668 short tons. Its 4884 wheel arrangement means it had 8 driving axles, a massive footprint to generate the necessary grip. The secret to its efficiency was its articulated design, allowing the front engine to pivot independently, enabling it to navigate curves while delivering unprecedented power. This massive machine could maintain high speeds while climbing steep gradients, a feat few other locomotives in the world could match. Its maximum tractive effort was an overwhelming 135 pounds-force. Only 25 of these magnificent machines were ever built, and their service life, though relatively short due to the rise of the diesel engine, was utterly transformative. They streamlined freight operations, reduced the need for helper engines, and symbolized the zenith of American steam power. Today, the surviving Big Boys, particularly the operational number 4014, draw millions of spectators, confirming their status not just as historical artifacts, but as enduring icons of pure, unstoppable American muscle. If Big Boy was the undisputed heavyweight champion, the Chesapeake and Ohio H8 Allegheny was the hidden contender, often cited as the most powerful steam locomotive ever constructed, challenging the Big Boy's sheer size. Built primarily to haul massive coal trains across the treacherous Appalachian terrain, the Allegheny needed brute force, not just speed. The H8, with its 2666 wheel arrangement, featured a massive expansive firebox that was necessary to generate steam at the required rate for continuous high-output performance. This locomotive generated an astounding 7,500 indicated horsepower, comfortably eclipsing the Big Boy. Crucially, its maximum recorded tractive effort stood slightly higher than the Big Boy's, officially reaching a staggering 141,600 pounds-force, making it arguably the strongest locomotive on paper. Its design was unique because of the 6-wheel trailing truck beneath the firebox, necessary to support the gargantuan weight of the boiler and firebox assembly, which was essential for generating that record-breaking power. The Allegheny's career was defined by relentless work in the heart of the coal industry. Operating on tight, winding mountain lines, their incredible power allowed for much longer, heavier trains than previously possible. While fewer were built than the Big Boys, their impact on coal logistics was profound. The debate over which locomotive was truly the largest often comes down to definition. Big Boy had the greater physical length, but the Allegheny possessed a superior power output, making it the king in the critical metric of raw strength. Shifting our focus across the globe, we encounter the Russian-class P-36, a locomotive that perfectly encapsulated the post-war ambition of the Soviet railway network. While not designed for the extreme tractive effort of the American giants, the P-36 was built for high-speed, long-distance passenger service across the vast, often demanding landscape of the USSR. Its large size was dictated by the sheer scale of the distances it had to cover. The P-36 was nicknamed General and immediately stood out due to its impressive, almost streamlined appearance and the iconic red stars decorating its front. Mechanically, it featured the classic 484 wheel arrangement, a configuration highly favored globally for high-speed passenger engines, providing both stability and power. It was the last large passenger steam locomotive designed in the USSR. Its sheer physical size, required to accommodate a large boiler and firebox for continuous speed, made it one of the largest passenger steam locomotives ever built outside of North America, capable of running up to 78 mph. These engines were the pride of the Soviet railway system, primarily operating on the flagship Moscow to Vladivostok route. They were designed for endurance and comfort, ensuring rapid transit across multiple time zones. With an operational weight of approximately 170 short tons for the engine alone, their imposing size and distinctive aesthetics serve as a reminder of the era when passenger travel across the vast Russian landscape was synonymous with the power of steam. The South Africa Class 25NC may not have the headline-grabbing tractive effort of the American articulated types, but its size and efficiency were dictated by one crucial factor: endurance over arid distances. Built to operate across the long, water-scarce lines of South Africa, the 25NC was an incredible engineering feat focused on operational self-sufficiency. This locomotive was a conventional, non-articulated 484 design, but its size was maximized for its unique operational environment. The most distinctive feature was the massive fully enclosed condensing tender. In South Africa's dry climate, water conservation was paramount. The condensing system allowed the steam to be recirculated and condensed back into water, significantly extending the operating range between water stops. This tender was enormous, contributing significantly to the locomotive's overall impressive length of over 111 feet and total weight of approximately 259 short tons, making it a truly large machine designed for massive self-reliance. The Class 25NC were the workhorses of the long-distance freight and passenger lines, especially the route from DR to Kimberley. Their condensing apparatus proved highly effective, allowing them to cover vast, often isolated areas with minimal support. While many were later converted to non-condensing NC versions, the original Class 25NC stands as a testament to specialized engineering. Its size was functional, a massive mobile ecosystem designed to conquer the environmental challenges of the African interior. The Pennsylvania Railroad Q2 represents one of the final massive attempts by the PRR, known for its standardized but highly effective designs, to build a dual-purpose locomotive, powerful enough for heavy freight but fast enough for time-sensitive movements. This locomotive, built during the heart of World War II, was an enormous rigid-frame beast, maximizing power without articulation. The Q2 featured the impressive 4-4-6-4 wheel arrangement, a unique configuration that employed a massive 6-coupled set of driving wheels. It generated incredible tractive effort without the complexity of articulation, making it simpler to maintain than the Big Boy or Allegheny. Its maximum tractive effort was a jaw-dropping 600 pounds-force. It was, in fact, the largest rigid-frame locomotive built on the PRR, and its sheer physical dimensions and power output placed it firmly in the category of the world's largest. The engine's design pushed the limits of what a non-articulated locomotive could achieve in terms of boiler size and resulting power. Serving predominantly during the high-demand wartime era, the Q2s were exceptionally powerful and fast, capable of hauling heavy trains at high mainline speeds. Unfortunately, the Q2s had a relatively brief career. Their complexity and the rapid post-war shift to diesel power meant their operational life was cut short. Nonetheless, the Q2 remains a towering example of a late-steam-era rigid-frame monster, a final great push by the PRR to maximize performance before the steam era's end. When we look at British steam, the definition of largest shifts to a focus on maximizing power and size within the nation's notoriously restrictive loading gauge, the tight tunnel and bridge clearances. The British Railways Class 9F was the ultimate expression of this constraint, arguably the largest and most powerful standard gauge conventional locomotive ever built in the UK, an absolute workhorse. Designed in the 1950s, the 9F was a massive 210 freight engine, a configuration that delivered exceptional pulling power. Its great size was dictated by its deep, wide firebox and large boiler, all squeezed meticulously within the narrow British clearance limits. It was the epitome of British standardization, designed to handle the heaviest freight traffic on any line in the country. To maximize its limited size, it utilized a sophisticated system that enabled high boiler pressure and efficient steam generation, delivering over 39,000 pounds of tractive effort. The Class 9F entered service late in the steam era but quickly became legendary for its reliability and immense strength. It was the final, highly advanced design produced by British Railways. Famously, one member of the class, Evening Star, was the last steam locomotive ever built for British Railways. Despite its primary role as a freight engine, the 9F proved surprisingly capable of high-speed running, with one unit unofficially recording over 90 mph. Its size is a testament to the skill of British engineers to pack such immense power into a physically constrained machine. The Southern Pacific GS4 represents the pinnacle of large, high-speed passenger locomotives, prioritizing speed and aesthetic size alongside power. These locomotives were the visual signature of the daylight passenger trains, running along the scenic California coast, a route that demanded both immense speed and an equally massive presence. The GS4, with its 484 wheel arrangement, was a huge locomotive designed for sustained high-speed operations. Its size was necessary to carry the large boiler required to maintain steam for long, continuous runs at speeds often exceeding 75 miles per hour. A defining feature, besides its iconic orange and red daylight livery, was the massive streamlined shroud that covered the boiler, making the engine look even more colossal and imposing. This engine was not merely large, it was styled to be large, conveying speed and luxury. These engines were the absolute celebrities of the Southern Pacific lines, hauling the famed Coast Daylight and other important passenger trains. Their reliability and speed were critical to maintaining the tight schedules of these prestigious services. With a total weight of approximately 437 short tons and a tractive effort of over 73,000 pounds-force, the GS4's massive physical size, combined with its high-speed capability and legendary status, cemented its place as one of the largest and most recognizable passenger engines in history. The German DR Class 45 stands as the largest standardized freight steam locomotive ever built in Germany, and indeed one of the largest conventional engines in all of Europe. Designed just before the outbreak of World War II, it was intended to replace existing heavy freight locomotives and provide the colossal power needed for the rapidly expanding German industrial rail network. The Class 45 featured the 210-2 wheel arrangement, chosen specifically for its phenomenal tractive effort, making it a genuine powerhouse. Its size was a direct result of housing the largest boiler ever built into a German standard gauge engine. This massive boiler was required to produce the necessary steam for sustained, slow-speed, heavy hauling. The sheer dimensions, with a length of nearly 78 feet, and the enormous boiler diameter put it near the limit of the European loading gauge, marking it as a truly gigantic machine for its operating environment. Its tractive effort was a respectable 58,000 pounds-force. These locomotives were the backbone of heavy freight traffic, especially during the wartime period when maximizing train loads was critical. Despite initial issues with boiler materials, the Class 45 proved its worth as a formidable haulage engine. Its legacy is one of pure, unadulterated strength, demonstrating how European engineers maximized conventional design to achieve colossal size and pulling capability, competing in scale with many American designs. Finally, we look at a different kind of giant, the articulated Garratt locomotive. The New South Wales Railways NSWGR Garratt 70 class was arguably the largest of its type designed for general service in Australia. The Garratt design inherently creates a visually and physically enormous machine by splitting the boiler between two separate engine units connected by an immense frame. The 70 class, with its 484 plus 484 wheel arrangement, featured two complete 484 engine units. This unique articulation allowed for incredible flexibility on tight curves and critically distributed the immense weight over more axles, reducing the axle load and making it suitable for lighter track infrastructure common in colonial and developing railway networks. Its total length reached approximately 108 feet, and its maximum tractive effort was nearly 60,000 pounds-force. Its length and overall mass made it a monster on the rails, designed to traverse long, challenging routes with minimal track damage. The 70 class was an essential tool for hauling heavy coal and wheat trains across the challenging terrain of New South Wales. While their service life was relatively short due to operational costs, they demonstrated the massive potential of the Garratt design. The sheer sprawling length of the 70 class Garratt makes it one of the most physically large locomotives in this list, a true titan that proves size can also be incredibly flexible. We have reviewed the giants, from America's colossal big boy and powerful Allegheny H8 to the unique engineering feats of Germany, Russia, and South Africa. These machines represent the undisputed apex of the age of steam. But the debate is never truly over. Which of these behemoths truly deserves the title of the greatest? Comment below right now and let us know your vote. If you were amazed, hit subscribe. We'll see you on the rails. Forget everything you think you know about steam power. We're talking raw, mechanical, fire-breathing speed. For decades, the fastest machines on the planet weren't planes or cars. They were these magnificent, forgotten giants of the rails. Today, we're tearing up the tracks to reveal the 10 fastest steam locomotives ever built that the history books barely mention. We're not just talking about the Mallard, we're talking about the PRR S1, the monstrous, almost mythical engine too big for its own good, and the German speed demon, the DR18201, which still holds insane records. Stay with us until the very end, because the true fastest is a machine you've certainly never heard of. Smash that subscribe button right now if you respect the power of a locomotive, and tell me in the comments, what's the top speed you've ever traveled on a train? Let's dive in. We begin our list with the undisputed icon, the British Speed King, the Elner Class A4 4468 Mallard. The reason Mallard is so famous is simple. On July 3, 1938, it achieved an incredible, officially verified speed of 126 miles per hour, 203 kph, making it the fastest steam locomotive in the world, a record that still stands today. This wasn't a fluke. The A4 class was specifically designed for speed by Sir Nigel Gresley, utilizing a distinctive aerodynamic streamlined casing that cut through the air resistance like a knife. Its loaded weight of approximately 165 US tons was perfectly balanced for express passenger service, prioritizing acceleration and top-end velocity on level tracks. The Mallard's record run, however, came at a cost. The third driving axle box failed shortly after the test run due to the intense forces generated at such extreme speeds. This highlights the engineering challenge of pushing steam technology to its absolute limit, despite its impressive size and power output. The locomotive weighed about 103 US tons without the tender, yet its power-to-weight ratio allowed for this incredible sprint. Despite the mechanical failure, the achievement solidified the Mallard's place in history as the ultimate benchmark for steam locomotion. Its sleek blue design remains a symbol of British engineering prowess. What truly makes the Mallard fascinating is not just the top speed, but the environment it was designed for. It primarily hauled the high-speed expresses between London and Edinburgh. The streamlined casing was more than just aesthetics. It played a vital role in carrying the exhaust steam up and away from the driver's sight, a crucial safety feature at those speeds. Even today, the site of the Mallard in the National Railway Museum remains a pilgrimage for anyone who wants to witness the physical embodiment of speed and ambition in the steam era. Its legacy is more than a number, it's a commitment to pushing boundaries. The German marvel, the DR18201, should be way more famous than it is. While the Mallard holds the historical record, the 18201 holds the title for the fastest operational steam locomotive in the world today. This green giant, built in East Germany in 1960, is a unique blend of components from other retired engines, making it a true Frankenstein of speed, but in the best way possible. The core of its speed is its enormous driving wheels, which measure over 7 feet, 2.1 meters in diameter, giving it the incredible ability to cover more ground per revolution. It was primarily used for test runs and high-profile special events, designed to reliably hit speeds of 110 mph, 176 km/h. This capability is remarkable considering its impressive working weight of nearly 155 US tons. Unlike many other speed attempts, the 18201 was built specifically for endurance at high velocity rather than a single all-out record attempt, making its sustained speed capability truly remarkable and reliable. This engine proves that consistent, high-performance operation can be just as impressive as breaking a short-term record. The survival and continued operation of the DR18201 into the 21st century is a testament to its robust engineering. While many steam locomotives were scrapped in the transition to diesel, this machine was preserved because of its unique role as a high-speed testbed and a national showcase. Its ability to achieve such speed despite its relative age highlights the ingenious design by the German engineers. It's a living piece of speed history, still thundering past at over 100 miles an hour today, connecting us directly to the peak performance of the steam age. If the Mallard was elegant speed, the Pennsylvania Railroad, PRR S1, was pure, unadulterated American brute force. Nicknamed the Big Engine, this legendary locomotive was an absolute titan and is arguably the most imposing steam engine ever built. Its sheer size was the problem. It was so long, measuring nearly 140 feet, 42.7 meters with the tender, it was difficult to navigate the tight curves and complex switch networks of many U.S. rail yards, essentially limiting it to straight, high-speed main lines. The S1 was built for one thing: speed and luxury on the express passenger routes, especially along the famed Broadway Limited. Though its official top speed was never formally recorded in a publicized manner, drivers routinely reported speeds exceeding 130 mph, 210 km/h. Its operating weight of around 250 US tons made this speed feat truly remarkable. Its unique wheel arrangement, 6446, was designed to deliver immense power while distributing its massive weight effectively. The lack of a verified record is partly due to the fact that hitting and sustaining those speeds was often too risky on the tracks of the time. Sadly, only one S1 was ever built, and it was ultimately scrapped after a relatively short working life due to its impractical size and the rise of diesel power. The legend, however, lives on. This locomotive represents the American desire to simply build the biggest, fastest, and most powerful machine possible, pushing the limits of technology regardless of practicality. It remains a fascinating what-if in railroad history, a true speed demon whose full potential was possibly never truly unleashed or recorded for the public. Let's jump back across the pond to another British masterpiece, the LMS Coronation Class 6220, specifically the iconic Coronation Scott Streamliners. This class was the direct rival to the Elner Mallard, a steam-powered arms race in the 1930s designed to capture the lucrative high-speed passenger market. The LMS team, led by Sir William Stanier, was determined to outshine the Elner's speed records, often running trains between London and Glasgow. The engine itself had a service weight of approximately 105 US tons without tender, designed for agility and power delivery. On June 29, 1937, the 6220 Coronation locomotive achieved a verified top speed of 114 metri, 183 km/h on the downhill stretch near Crewe. More impressively, during a test run, it reportedly hit an unofficial terrifying speed of 116 metri, 187 km/h. The pursuit of speed was so intense that the engine even famously overshot a platform due to its incredible momentum and the short distance required to stop from such speeds, a clear sign of the engineering limits being tested. This demonstrated the immense kinetic energy of a fast-moving object weighing over 100 tons. What truly sets the Coronation class apart is its unique combination of power and handling. While the A4 was a pure sprinter, the Coronation was known for its ability to maintain high speeds over long distances, making it a supremely efficient express engine. Like its rival, it featured a distinctive streamlined casing, originally painted a stunning blue and silver, symbolizing the forward-looking modernity of the era. The underlying power and speed of the Stanier design kept these magnificent engines running fast and reliably for decades, solidifying their place among the fastest ever built. When we talk about American locomotives, you can't ignore the sheer scale and power of the Union Pacific Big Boy 4000 series. This machine is legendary, often cited as the largest steam locomotive ever built, with a staggering total operating weight of over 600 US tons. What many people overlook is its remarkable capability for speed despite its size. Designed in 1941, the Big Boy was initially intended to haul massive freight loads over the steep grades of the Wasatch Mountains in Utah, a task that demanded incredible tractive effort and raw horsepower. The engineers designed it to operate at a continuous speed of 80 mph, 129 km/h, even while pulling trains weighing thousands of tons. However, during light load test runs, the Big Boys were consistently reported to achieve speeds well over 100 mph, 160 km/h. This makes the Big Boy perhaps the only freight locomotive in history that could legitimately compete with the world's fastest passenger engines, a truly astonishing feat of engineering for a machine designed primarily for brute force rather than outright velocity. The secret to its speed lies in its immense articulated boiler and its high driving wheel diameter. The recently restored Big Boy 4014 thundering across the plains today is a reminder of this unique combination, the world's largest engine that was also secretly one of its fastest. It represents the American desire to solve problems with sheer scale, transforming freight handling in the West. This machine proved that power and speed were not mutually exclusive, even when hauling gigantic trains across the vast American landscape. Before the Big Boy, there was its predecessor, the Union Pacific Challenger 4664, epitomized by the famous 3985. This class of locomotives was introduced in the 1930s to handle fast freight and heavy passenger trains on Union Pacific's mountainous routes. The Challenger was explicitly designed as a high-speed, multi-purpose engine, making it one of the most versatile and efficient steam locomotives ever constructed. Its impressive operating weight of around 230 US tons, engine only, gave it the traction needed for those high-speed demanding tasks. While its official operational speed was set around 70 mph, the Challenger class was known to comfortably and reliably hit speeds of 90 to 100 mph, 145 to 160 km/h during service. Its design was a crucial stepping stone between the earlier, less powerful engines and the gigantic Big Boys. The Challenger's smaller size compared to the Big Boy allowed it to operate on a wider variety of track sections and switch yards, giving it an operational flexibility that its larger counterpart lacked, making it a high-speed workhorse across the western U.S. The restoration and continued use of the 3985 as an excursion engine proved its enduring appeal and reliability. Enthusiasts loved the Challenger because it was the perfect blend of power, speed, and efficiency. It could haul a long, heavy train up a steep mountain pass and then switch gears to race across the plains at near triple-digit speeds. The Challenger truly represents the zenith of the articulated locomotive design, proving that you could have both massive pulling power and incredible high-speed capability in a single, well-balanced machine. Next up is an engine that embodies both beauty and raw speed, the Norfolk and Western J-Class 611. Built for the N&W's passenger trains, this locomotive was an absolute stunner, featuring a sleek, modern, streamlined design that rivaled the British streamliners but was purpose-built for the challenging terrain of the American South. The J-Class was considered the ultimate example of a passenger locomotive designed and built in-house by a major U.S. railroad. It was a heavyweight for speed, with a service weight of about 215 US tons. Engineers specified that the J-Class must be capable of hauling 15 passenger cars at speeds of 80 mph, 129 km/h, on straight tracks, and it consistently exceeded that. Test runs and anecdotal evidence from engineers frequently cited speeds well over 100 BCM, 160 km/s. Unlike many other high-speed engines which specialized in flat runs, the N&W 611 was equally adept at maintaining high speeds while climbing the steep grades of the Appalachian Mountains, a testament to its highly efficient boiler and perfect balance of speed and power required for long-distance runs. The 611's enduring popularity is due to its impressive operational record and its current role as a star excursion engine. It was known for its incredible reliability, often running thousands of miles between major service overhauls. The 611 is not just fast, it's a symbol of American mechanical perfection and reliability, demonstrating how a locomotive, designed for demanding routes, could still deliver a high-speed, smooth, and powerful performance that delighted passengers and thrilled engineers alike. It's truly the Southern gentleman of speed. This is one of the deep cuts you probably didn't know about, the South African Railways Class 25. Why is this massive machine on a list of the fastest? Because speed isn't just about the top number, it's about sustained speed and endurance over vast, unforgiving distances. The Class 25 was built for the long, arid runs across the Karoo Desert and other demanding South African routes, where conditions required both power and reliability at high velocity. Its powerful nature meant an engine-only weight of around 130 US tons. The Class 25 was one of the last and most successful steam designs in the country, and its main claim to fame is its highly distinctive condensing tender. This innovative feature recycled the steam back into water, allowing the locomotive to operate for incredibly long distances, sometimes up to 500 miles, without taking on water, which was a critical necessity in water-scarce regions. While designed for a working speed of 65 mph, in the long, flat stretches of the South African plains, they were frequently recorded hitting speeds close to 90 mph, 145 km/h. The fact that these condensing engines could maintain high average speeds for thousands of miles through the harsh desert environment is what earns them a spot here. They demonstrated a level of endurance and high-speed operation that few other steam engines in the world could match under such severe operational constraints. The Class 25 shows us that true speed often comes down to innovative engineering designed to overcome logistical hurdles, making it a unique and powerful entry on our list of the fastest engines. Jumping back to Britain, we have the elegant and highly efficient GWR 4073 Castle class. This was the Great Western Railway's answer to the need for a fast, light, and powerful engine for their high-profile passenger services, most notably the famed Cheltenham Flyer. The Castle class, designed by Charles Collett, was considered the pinnacle of GWR steam design. Its engine-only weight of roughly 100 US tons made it highly efficient without sacrificing power for speed. The Castle class holds a significant historical place as one of the first steam engines in Britain to regularly exceed 100 mph shows, 160 km/h during service. One of the most famous runs was in 1932, where the 4082 Windsor Castle achieved a top speed of 102 mph. This was a crucial milestone, as it proved that high-speed running could be achieved reliably and economically, even with a locomotive that was relatively light compared to some of its American or German rivals. This performance placed it squarely in the top tier of international speed machines. What made the Castle class so fast was its superb balance of a large boiler and light-moving parts, making it extremely efficient and fast to accelerate. The GWR engineers were masters of lightweight design and careful balancing, which reduced dynamic forces and allowed for higher sustained speeds. The Castle class represents the epitome of British express passenger service, fast, reliable, and perfectly suited to the highly competitive intercity rail network of the era, proving that sometimes clever design beats sheer size. Finally, we come to the 34028 Eddystone, part of the Southern Railways SR, West Country, and Battle of Britain classes designed by Oliver Bulleid. These were smaller, lighter, and more agile engines built for the challenging, often coastal routes of southern England. While not built for headline-grabbing, one-off records, they were incredibly fast and robust performers in daily service. Their streamlined look and engine weight of about 100 US tons, engine only, made them perfect for rapid acceleration and speed on lighter tracks. The design of the Bullard Pacifics was radical, featuring an unconventional oil bath valve gear and an almost futuristic look. This design allowed them to be exceptionally powerful for their size and weight. While many records are anecdotal, these light engines were frequently observed hitting speeds of 105 to 110 mph, 169 to 177 km/h, particularly on fast downhill sections of their route. Their lightweight construction allowed them to run on lines with lower track strength, making high-speed travel possible where heavier machines like the Big Boy couldn't tread. The Eddystone and its sister engines are often overlooked, but their operational speed and reliability under challenging conditions make them true speed demons. They represent the final daring innovations of the steam age in Britain, proving that you didn't need the biggest engine to achieve incredible speed. They were fast, efficient, and they quietly revolutionized express travel across the south of England, securing their place as one of the fastest, most underrated locomotives of all time. Wow! From the streamlined perfection of the Mallard and the sustained power of the DR 18201, to the immense mythic speed of the American PRR S1 and the freight-hauling capability of the Big Boy, we've seen the absolute limits of steam technology. These magnificent machines weren't just fast, they defined their eras. The next time you think of speed, remember these iron giants. Hit that like button if you were surprised by the PRR S1's true speed, and share this video with a friend who loves engineering. Don't forget to subscribe and turn on notifications so you don't miss our next deep dive into forgotten technology. Thanks for watching. In the annals of human ingenuity, few machines command the raw respect and awe of the great locomotive. They are more than just steel and fire, they are monuments to the limits we dared to push. For over a century, engineers relentlessly pursued a single goal: power. To move more, to go faster, to conquer mountains and deserts with sheer mechanical force. Today, we delve into the heart of that ambition. We are counting down the 10 largest and most powerful locomotives humanity ever placed on rails. The sheer size of these iron giants, the articulated steam beasts, the colossal diesel electrics, and the specialized monsters will challenge everything you think you know about rail travel. First, a challenge for you. Before we even start, hit that subscribe button and tell us in the comments which locomotive you think will claim the title of the undisputed king. Can the Big Boy be beaten? Let's find out. We begin with a machine that defied its time and shattered expectations, proving that raw power wasn't limited to sheer bulk. This is the MOV 242.001, a sleek 4-4-4 steam engine born in Hungary in 1937, designed not for pulling coal but for blistering speed. Its white notation, the 444, denotes 4 leading wheels, 4 coupled drive wheels, and 4 trailing wheels, giving it remarkable stability at velocity. But don't let its comparatively slender frame fool you. This was a technological pioneer. The Speed Demon was designed by the renowned Hungarian engineer Ferenc Liptak, specifically to haul heavy express passenger trains across the flat plains of Hungary at phenomenal speeds. It wasn't the largest, but it possessed immense power-to-weight ratio and a groundbreaking streamlined casing that dramatically reduced air resistance, a true marvel of pre-war European design. Its confirmed top speed approached 140 km/h, 87 mph, making it one of the fastest of its time, easily forming many contemporary designs built for sheer brute force. Its service life was tragically cut short by the chaos of World War II, during which the original locomotive was lost. However, its memory and its engineering legacy persist, demonstrating that the pursuit of speed was just as intense as the hunt for tonnage capacity. It showed that streamlined design could unlock hidden power, From high-speed runs, we turn to the grueling, water-scarce environment of South Africa. Meet the South African Railways Class 25, a powerful and unique 484 steam locomotive designed to tackle one of the continent's most challenging problems, water scarcity. Introduced in the 1950s, this wasn't just a powerful engine, it was a self-sustaining ecosystem built on rails. The true genius of the Class 25 was its revolutionary condensing tender. In most steam engines, steam is exhausted into the atmosphere, wasting precious water. The Class 25, however, routed the exhaust steam through massive air-cooled radiators in its tender, turning it back into water for reuse. This allowed the engine to travel vast distances, up to 800 miles, without taking on water, making it the perfect workhorse for the arid Karoo region. The 25C variant, the condensing model, made the engine heavier and bulkier, adding to its impressive stature. This feature was absolutely critical for maintaining the efficiency of South Africa's vast railway network, often hauling heavy freight and passenger traffic. The sheer reliability and operational savings the condensing system provided allowed the Class 25 to remain in service for decades, long after many other countries had transitioned away from steam. Its 484 wheel arrangement provided the perfect balance of pulling power and high-speed running capability. Back in the United States, we encounter one of the most beautiful and effective steam engines ever conceived, the Norfolk and Western J-Class 611. Built by the N&W's own shops, this 484 streamlined queen was the crown jewel of their passenger service. Combining elegance with incredible power, the J-Class could maintain speeds over 100 km/h while effortlessly pulling heavy passenger consists, making it an icon of American railroading. The N&W 611 was a masterclass in balance and efficiency. Its design prioritized high-speed stability and low maintenance, boasting roller bearings on all axles, a state-of-the-art feature for the 1950s. While not the largest by overall dimensions, its horsepower output was phenomenal for a conventional 484, ensuring it remained punctual regardless of the terrain of the Appalachian Mountains. The engine was an immediate success, known for its smooth ride and capacity to handle the fastest schedules across the N&W lines. What makes the 611 truly legendary is its survival and subsequent return to mainline service. It's one of the few steam locomotives that has run at speeds that rivaled and often exceeded modern diesel passenger units, proving the enduring capability of its design. The streamlining was more than cosmetic. It was a functional part of its high-speed performance, setting a visual standard for passenger trains that is still admired today. The 611 represents the peak of standardized high-performance steam passenger technology in the U.S. Next, we honor the pioneering spirit of the Atchison, Topeka, and Santa Fe Railway with the Santa Fe 5000, known affectionately as the Madame Queen. This was a landmark locomotive, the first 210-4 type built in the United States and a true champion of heavy freight hauling. Delivered in 1930, the Madame Queen was designed to conquer the challenging grades of the Santa Fe's western lines, particularly the legendary Abo Canyon route in New Mexico. The 210-4 wheel arrangement, meaning 2 leading wheels, 10 massive driving wheels, and 4 trailing wheels, was revolutionary. The 10 driving wheels gave it an unparalleled adhesion and the sheer tractive effort required to pull heavy tonnage over steep inclines. The 4-wheel trailing truck was essential to support its enormous firebox, allowing the locomotive to generate the vast quantities of steam needed for a continuous, high-output operation. This combination of tractive effort and steaming capacity made it an instant success. The performance of the single Santa Fe 5000 was so spectacular that it led to the rapid development of the subsequent and highly successful 2-10-4 classes, often known as the Texas type, a name that later became common. The Madame Queen proved the 2-10-4 configuration was superior for the grueling tasks facing American heavy freight railroads in the era, setting the blueprint for massive freight power for the next 2 decades. Our journey now takes a dramatic turn across the Atlantic to the Soviet Union, where sheer size was often an expression of national pride and industrial might. Here is the Soviet AA-21, a steam locomotive so massive, its wheel arrangement is almost impossible to comprehend, the staggering 414-4. This single experimental engine holds the world record for the most driving axles on a single rigid frame, 7 sets of coupled wheels. The AA-21 was constructed in 1934 and was intended to be the ultimate freight hauler on the Soviet railway network. The logic behind the 14 driving wheels was simple: to maximize the engine's adhesion and distribute the colossal weight of the locomotive across the tracks. The Soviet engineering marvel utilized an articulated frame and a massive boiler to attempt to achieve unparalleled pulling power, a true statement of Stalinist industrial ambition. However, the AA-21 was a classic case of ambitious engineering exceeding practical infrastructure. Its immense size and rigid frame proved incompatible with the sharp curves and standard track infrastructure of the Soviet railways. The excessive length and weight resulted in frequent derailments and track damage, meaning it spent more time in the shop than on the main line. Despite its technical failure, its existence remains a potent symbol of the global race to build the biggest, most powerful machine imaginable. Not all power is measured in tractive effort. Sometimes it's measured in sheer, unstoppable force against nature. The Union Pacific Rotary. Snowplow is a highly specialized, self-contained machine designed for one purpose: to annihilate blizzards. While technically not a locomotive that pulls freight, it is a mobile powerhouse that clears the way for all other locomotives, demanding immense power to operate its main feature, the massive rotary blade. These plows were indispensable in the mountainous, snow-prone regions of the western United States. Unlike traditional wedge plows, which merely push snow aside, the rotary plow uses a colossal, rapidly spinning wheel fitted with blades to chew through drifts up to 20 feet high, throwing the snow clear of the tracks. The power required to turn this wheel against compacted snow and ice is immense, often requiring 1 or 2 powerful locomotives, often Challengers or big boys, to push the plow forward and another one to power the rotary mechanism itself. The rotary snowplow represents the ultimate extreme of engineering adapted to environmental challenges. When the line was blocked, hundreds of tons of freight and passengers were paralyzed. The arrival of the Blizzard destroyer, often powered by a tender full of oil and fire, signaled the immediate resumption of traffic. It is a spectacular and terrifying machine in action, a true spectacle of raw mechanical work. We now arrive at one of the workhorses that truly define the American West, the Union Pacific Challenger, specifically the 3985. The Challenger, a 4-664 articulated locomotive, was developed in the 1930s to handle the rapidly increasing tonnage on the Union Pacific Railroad. It was slightly smaller than its famous cousin, the Big Boy, but designed for high-speed freight service, making it an incredibly versatile and powerful machine. The key to the Freight Titan's versatility lay in its articulated design, allowing the long wheelbase to navigate curves that would have been impossible for a rigid-frame locomotive of its size. The 4-664 configuration meant it had 2 sets of 6 coupled driving wheels, giving it enormous tractive effort, yet it was engineered to cruise comfortably at speeds nearing 70 mph, a remarkable feat for a machine built primarily for freight hauling. It became the backbone of UP's fast freight operations, seamlessly bridging the gap between slow, brute-force engines and high-speed passenger locomotives. The 3985 itself, one of the last Challengers built, has achieved a special legendary status in preservation. Its successful operation demonstrated that large articulated steam power could be highly efficient and adaptable. The Challenger proved that railroads needed a powerful machine that could haul colossal weight and maintain a respectable schedule, a crucial factor in the competitive U.S. rail market. If there is one locomotive that truly challenged the Big Boy for the title of most powerful steam locomotive, it is the Chesapeake and Ohio C&O H8 Allegheny. This 2 or 6 articulated monster was built specifically to haul heavy coal trains over the steep grades of the Allegheny Mountains in West Virginia, a task that demanded the absolute maximum output possible from a steam engine. The Allegheny's distinguishing feature was its 2-to-6-6-6 wheel arrangement, incorporating a unique 6-wheel trailing truck. This was necessary to support its massive, high-capacity firebox, which was the largest ever installed on a steam locomotive. This firebox was the engine's heart, designed to generate steam pressure at an incredible rate, pushing its horsepower output up to a claimed 7,500 horsepower. This immense power rating made it arguably the most powerful reciprocating steam locomotive ever built in terms of horsepower developed. The size of the Allegheny was astonishing. It was one of the heaviest and most intimidating locomotives ever to run, primarily serving the grueling coal traffic routes. Its raw power ensured that the C&O could move vital coal supplies efficiently, cementing its reputation as the power king of the eastern railroads. The rivalry between the Allegheny for horsepower and the Big Boy for tractive effort weight is one of the most famous debates in rail history. Stepping into the modern era, we encounter the true king of diesel electrics, the EMD DDA-40X Centennial. Built by Electromotive Division, EMD, for the Union Pacific Railroad, this monumental locomotive was unveiled in 1969 to commemorate the 100th anniversary of the completion of the Transcontinental Railroad. It is to this day the longest single-unit diesel locomotive ever built. The Diesel Goliath is essentially two powerful diesel-electric units combined into one enormous 98-foot-long rigid frame. It was powered by two separate 16-cylinder diesel engines, providing a combined output of 6,600 horsepower. The DDA-40X was designed for high-speed freight service, often working across the flat plains and mountainous regions of the Union Pacific system. Its sheer size required a modified version of the DD axle arrangement, which spread the weight and power across 8 axles. The Centennial demonstrated the peak capabilities of U.S. diesel engineering. It offered unparalleled reliability and required significantly less maintenance than the steam engines it replaced. The ability to haul the heaviest trains at higher speeds with a single crew was an economic game-changer for the railroad. Only 47 of these unique units were ever built, and their legacy remains unchallenged as the longest and one of the most powerful diesel locomotives in continuous service. We have arrived, holding the title that all others measure themselves against, the Union Pacific Big Boy. This colossal 4884 articulated steam locomotive is widely regarded as the largest and most powerful steam engine ever to operate globally. Built in the early 1940s, the Big Boy was designed for one overwhelming purpose: to haul 4,000-ton freight trains unassisted over the steepest grades of the Wasatch Mountains. Its engineering was simply staggering. The 4884 wheel arrangement means it had two massive engines built into one frame, giving it the ability to articulate and navigate curves. It measured over 132 feet long, including the tender, and developed an enormous 135,375 pounds of tractive effort, a figure that remains unmatched by almost any other locomotive ever conceived. It was the ultimate weapon in the battle against gravity and immense tonnage. The Big Boy was so effective that it fundamentally changed the logistics of the Union Pacific, making double-heading, using two locomotives, unnecessary on its toughest routes. Of the 25 built, 8 survive, including the famed UP 4014, which has been returned to operational status, thrilling crowds worldwide and proving that its decades-old design can still dominate the tracks. The Big Boy is not just a machine, it is a mechanical legend, the undisputed symbol of power on the rails. We've witnessed the Speed Demon, the Desert Workhorse, the Power King, and the Diesel Goliath. These 10 machines, from the rapid MAV 242 to Z01 to the gargantuan Big